Hello.
Yeah, hi. So we're just getting started. Yeah. If I wasn't quite sure if we were still waiting for additional participants. Um, so let me know and I can happy to get us started. Great. And Brian, if you could tell me when we've hit, I can't quite see the number of participants. I've lost my, excuse me.
Hey, Morgan, I can do. We have a few more folks joining us.
Okay.
We'll maybe give it a few more minutes and then
Sure,
I'll let you know
sure.
when we can kick off.
Great. I'm just getting my my presenter view back. So, okay.
Great. Looks good here.
Great.
Thanks. Okay, looks like we can get going, Morgan.
Great, thank you. So welcome everyone to this NeuroTechX Buzz in Review 2021. My name is Morgan and I'm a chapter lead in San Francisco. I'm joined by chapter leads in Salt Lake and Vancouver, and as well as others. And it's a pleasure to have you here.
Okay, looks like we can get going, Morgan.
So Buzz in Review is something, I believe the history is that it's, welcome everyone, yes, it started to this NeuroTechX at least as a pilot in 2017. And I certainly remember it was the first event that NeuroTechX San Francisco did last February, I believe. It was the first event that I hosted, and it was an incredible event for outreach. And yeah, 8 chapters participated last year, and it looks like we're going to pass that this year. As you can see, a number, I mean, a really global community is participating. So for those who aren't familiar with NeuroTechX, NeuroTechX is an international community for neurotechnology enthusiasts. It's an international community that facilitates the advancement of neurotechnology. And the pillars of our pillars of NeuroTechX are community and brain technology that needs diverse and dynamic community of experts, entrepreneurs, and enthusiasts. And the community really brings all that diverse community together. Education is a big part, and NeuroTechX offers accessible resources and learning opportunities for beginners or experts. And check out learn.neurotech.edu.com. And innovation. We hope to inspire our community members to address today's challenges and opportunities with creativity and confidence. So it's been wonderful to see, you know, the growth over 5 years, as this is a 5-year anniversary. We just passed 5-year anniversary for NeuroTechX. There are community members everywhere. There are global events happening all over the place. And it's even just in the last year, I think we added something like 8 chapters. But as a thriving online community in Slack and other venues, and the volunteer-led initiatives are another big part of the kind of community involvement, and they are wide and diverse, and we'll cover those later. So I want to thank Curia for sponsoring us this evening, and this is a annual event that we have been so proud to have them be a part of. So I'm going to turn that over to the next speaker. And the next person, yeah.
All right, great. So thank you, Morgan. So I'm going to continue talking about some of the big trends in 2020 that we saw in our community. So moving on, one of the biggest, it was a great year for Kernel. Last year, earlier in May, they raised about $53 million in Series C funding, and ultimately their goal is to offer Flux and Flow, which are 2 different products via a neuroscience as a service model. So this is a big thing because usually technologies that allow us to look at brain activity are expensive and are only offered to some people, whereas Kernel's goal is to make it more commercially available. And what Flux does is it uses optically pumped magnetometers to detect magnetic fields created by the collective activity of neurons, whereas flow measures blood through the brain, blood flow through the brain. Later in October, Kernel revealed Flow, which is the first commercially scalable time domain near infrared spectroscopy system in history. And then later in November, Kernel combined flow with virtual reality. It They used the Neo 2i VR headset and added kernel flow modules to look at the prefrontal cortex. So specifically, as a proof of concept, they looked at a working memory task, which working memory is um, under the prefrontal cortex, and they had one patient where flow. So sorry, they combined in a single subject. They combined flow with VR. And later in December, which is fairly recent, we entered the kernel flow 50 phase 1, where 23 flow systems were awarded to elite academic and industry groups. So it's been a great year for Kernel. Not just for Kernel, it's been a great year for Synchron as well, and for obviously for the broader neurotech community. Synchron in July received about 1 million Australian dollars from the Australian government to explore Centroid. So Centroid is designed to function as a neuroprosthesis and a neuromodulation device. It is implanted.
Sorry. Do you think you could full screen your slides?
Oh, I'm so sorry. Thanks for
No.
pointing it out.
Sure. No problem. Thank you.
I am technically challenged. How do you?
Just 1 second. Yeah, I had to do the same thing.
Great. Thanks, Morgan. So Synchron, Synchron received funding to further explore their product Centroid. So Centroid is a BCI that's implanted through the jugular vein. So it's great because it bypasses open brain surgery. And it functions both as a neuroprosthesis and a neuromodulation device. It's implanted next to the brain's motor cortex. And in December of 2019 was when we saw the first successful clinical implementation of the Centroid. So what's great is the funding that the Australian government received. For just to investigate Centroid is a collaborative project, and earlier the University of Melbourne received about $1.5 million as well through the National Health and Medical Research Council grant to investigate Centroid. And later in August, we were fortunate to see the results presented at the Society of Neurointerventional Surgery at the 17th annual meeting. So they presented the first in-human examination. It was a successful presentation, which led to the FDA announcing it, designating it as a breakthrough device later in August, in the very same month. And in October, we read the results of their first in-human study, which was published in the Journal of Neurointerventional Surgery. So patients use Centroid to text, email, shop, and bank online. And it's possible because Centroid, it allows the control of external devices, such as, for example, a personal computer, through direct thought alone. Moving on, one of the other neurotech devices that we saw great breakthroughs in were our prosthetics. Specifically, earlier in March, we saw the University of Michigan come up with a new approach. It's called the regenerative peripheral nerve interface. So what they did is implant surgically attach a small graft of muscle tissue to the end of a severed nerve in an amputee's arm. So what RPNI does is it promotes healthy nerve growth and acts as a bioamplifier, and converts faint neural signals that are sent from the brain into large recordable muscle signals. Ultimately, over time, these signals are combined with machine learning algorithms and allow for real-time mind control of advanced robotic prosthetic hands. So it's fairly intuitive. And you can see what it looks like here in this picture as I'm pointing out with my cursor. Later in July, and this story is great because the end user became the developer. And we can see that in the picture here down below. And this is a hand of Ian Davis. In early 2019, he lost 4 of his digits on his left hand to work accident. Unfortunately, his insurance did not cover the prosthetic. So he used his mechanical engineering background to create his own device. And this device, instead of using electronics, uses mechanism to function. And later in July, I think this YouTube video linked here is great because in this video he showed that his device now comes with display functionality. And later on in the very same year, we see that Atom Limbs, which was just founded a year ago, reveals their prosthetic called Atom Touch. Atom Touch has about 200 sensors, which enables it to which gives it 4 types of touch sense, including contact, force, position, and velocity. Unfortunately, it requires surgery, and which is why that functionality is still in beta mode. But ultimately, Atom Limbs is great because it is controlled by thinking, and the 200 sensors allow in addition to other things allow users to move individual fingers and give them a sense of touch. Moving on, and the year ended with a bang because TeleSuit Glove, which is an interface designed to simulate experience and accelerate mastery, was revealed at the end of last year. And you can also see TeleSuit at a Neo Gaming event. You can definitely see the link down below. And TeleSuit is great because it's not just, they model their device for use, not just for rehab, but also in government, for government services, as well as in enterprise. So it covers more end users. So TeleSuit it adds immersion as well. So it adds immersion that will amplify usability testing, human factors projects, product engineering, and technology development programs. It's the world's first compatible VR glove that uses haptics, motion capture, biometry, and force feedback to tailor their product to the user. So it's great, basically. Moving on, these were some of the moving on from some of the big trends in 2020. We'll now talk about the big news or upcoming things that have been done on the research side of things with the use of neurotechnological devices. For example, we see that in March, Nature published a paper which reported the use of epidermal electronic devices, specifically tattoo electrodes. They used these tattoo electrodes they use these tattoo electrodes to demonstrate. They use these custom-made skin phantom. They use these tattoo electrodes to demonstrate inkjet printed conducting polymer tattoo, and it shows that it can be used in clinical EEG. They also demonstrated its compatibility with MEG. It's good for quality recordings over time. It's conformal because of its conformal and has imperceptible contact. In addition to these conducting polymer tattoo electrodes, we also saw Nature reveal another ultra conformal drawn skin type of electronics, which came up in July. These drawn skin electronics are great because they allow for them to be used in clinical settings to measure brain activity, which is more portable when compared to some of the other big devices that we see, for example, an fMRI machine or a PET scanner, and they're huge and very expensive. So basically, in July, Nature published another paper where we see these drawn skin electronics being used, and they show that these drawn skin electronics are great for monitoring health, disease prevention, and treatment, and it's another step up in wearable electronics. And yeah, it's great to see the use of such bioelectronics. Moving on later in the year, it's been great year for research because we see the use of implanted electrodes with patients with vision problems. So what this paper that was published by the researchers at the Baylor College of Medicine in Houston in the journal Cell on May 14th, they used electrodes, implanted electrodes, which used a dynamic sequence. Essentially, what they did is trace shapes on the surface of the visual cortex, which allowed the participants who are essentially blind to be able to see. It's a lot better than past techniques, which treated each electrode like a pixel and visual display, and that they were stimulated at the same time. Now that allowed the participants to definitely detect spots of light, but they were not able to differentiate between different patterns. They weren't able to see forms or visual objects. So basically, the first author says that our inspiration of this idea was our inspiration for this was the idea of tracing a letter in the palm of someone's hand, and it's great because blind patients do describe seeing glowing spots or lines forming the letters like skywriting. So the investigators have tested this approach in four sighted people so far who had electrodes implanted in their brains to monitor epilepsy, and 2 blind people who had electrodes implanted over their visual cortex as part of a visual cortical prosthetic device. It'll be great to see whether they can scale it to other patients and its use in treatment. Now moving on to prosthetics again. So it's been a great year for prosthetics, the use of prosthetics in rehab, not just from the tech side of things, but also in actual research, where in July, we see that the University of Pittsburgh's Rehab Neural Engineering Labs released or talked about the use of spinal cord stimulators. So what they did is they repurposed these stimulators to restore touch in lost limb. So when turned on, these stimulators, which up until July, as far as we know, have been piloted in 4 amputees. The article is published in eLife. You can definitely search it up. So these stimulators, when turned on, they created the illusion of sensations in the missing arm. And it's very cost friendly because they basically use the devices that were already implanted in 50,000 people. Moving on, later on in August, the very next month actually, researchers at EPFL and Lausanne University Hospital were able to get animals with damaged spinal cords walking again. So what they did is they restored mobility by identifying the by identifying the neurons using artificial intelligence, by identifying the neurons which are involved in the gait reacquisition process. Now, so far it's been successful in rodents, and we'll see whether they can also do the same in humans. And this paper has been published in Nature. Moving on to another piece of news for the vision world. Researchers at the Monash University published on a first of its kind device that can restore vision to the blind. So this study so far has been done on it's non-human trials on sheep and a few other clinical studies as well. And researchers are now preparing for the first human clinical trial. And what essentially this restoration device does, it combines smartphone style electronics and brain implanted micro electrodes to restore vision. They do anticipate that they do not anticipate any adverse health effects because when 10 of these arrays were implanted in sheep, after a cumulative total of about 2,700 hours of stimulation, they didn't see any adverse effects. So hopefully hopefully it should be pretty much safe for humans as well. And just to go into a little bit more detail, because I think it's pretty cool. This device is pretty cool. What the restoration device essentially does is it translates information gathered by a camera, and this information is then interpreted by a vision processor unit in custom software wirelessly to a set of tiles that have already been implanted within the brain. So these tiles convert the image data to electrical impulses, which are then transmitted to neurons in the brain via microelectrodes that are thinner than human hair. So it's not completely, it's a little bit invasive, so fingers crossed. That's pretty much it from my side. Going to pass this to someone else. Okay, moving on. So moving on, let's talk about some technological innovations that also occurred last year. We have Zeto's EEG, Neurosity Notion 2.0, OpenBCI Gallia, and GTech Pangolin. So these non-invasive consumer neuroimaging is great because it's somewhat portable when compared to bigger devices, and naturally, as the name says it, they're non-invasive. So just to go into a little bit more detail, Zeto's instant EEG platform, it provides the first FDA-cleared zero-prep wireless dry electrode headset that can then be used to perform a routine or urgent EEG anywhere without the need for a trained expert. So it's great for on the ground use in remote places like certain northern communities, or maybe it's also great for use in used by, I guess, military personnel who can then just carry it really anywhere. And then we have Neurosity's Notion. Notion combines brain imaging, a powerful CPU, RAM, internet connectivity, and onboard machine learning with the power of a laptop and comfort of a wearable. Notion has everything that you need to build powerful powered apps. So again, it's great for using research and in industry. Moving on, GTech Pangolin is the world's first ultra high density electrode grid and biopotential amplifier system. It works with active electrode technology to measure EEG and EMG or other body signals. G-Family is connected to GH-Lamp, which is a multi-channel back-end biopotential recording device, and it can acquire biosignal with 24-bit resolution and a sampling rate, which is pretty great, up to 38,400 hertz per channel. So, it allows for 1.024 EEG channel recordings. These are just some examples of some details on some of these neuroimaging devices. Stimulation, it's also been a great year for stimulation/modulation devices. For example, NeuroRhythm, it's the first gesture-controlled headband that's proven to be effective for consumers to help improve their sleep, increase relaxation, sharpen focus, and help manage pain. Cove is the first product from Fillmore Labs. It's a wearable device that applies gentle silent vibrations just behind your ears on the mastoid and temporal bones. The specific frequency of the vibration is designed to stimulate the sensitive nerve endings of your skin into activating a deep part of your brain, particularly the posterior, for example, the posterior insular cortex that is directly involved in the modulation of stress. Then finally, we have the NeuroFUS Buzz Pro. It's great for transcranial focused ultrasound neuromodulation. It's a revolutionary new system. This system can be used to administer low intensity pulse transcranial ultrasound, so TPUS for short, to the human brain, and enabling unprecedented high spatial resolution and neuromodulation of sites beneath the cortical surface. And again, like all these devices, it's great because it's portable and it can be used in remote, in medical clinics, but in particularly in medical clinics that are in remote mountain communities who could be probably far away from the nearest hospital that have such devices. To end off, I'd like to end off a little bit. I'd like to end off with a little bit more detail on the Galea. So Galea is a hardware and software platform that merges next generation biometrics with mixed reality. This is the first device that integrates EEG, EMG, EDA, PPG, and eye tracking into a single headset. And I mean, it's fantastic. It cannot get any better than that. The Galea hardware will be integrated into existing AR and VR head-mounted displays and will include SDKs for bringing rich and tightly time-locked biometric data into 3D development engines, third-party applications, and all common programming languages. So it's great because it allows for the collection of dynamic data sets with the use of just a single device instead of buying large equipment, and that could be more than one usually is more than one in number. So it's cost effective and it's space effective. Moving on to our next slide. The Paradromix unveils the largest ever electrical recordings in the brain. So again, let's break it down a little bit. What's Paradromix? Paradromix is the first Paradromix is a company that has revealed its first product. Its first product will be a communication device for patients with severe paralysis. This device called the Argo, and you can read their paper. It's in BioReciv. I'm sorry if I'm pronouncing it incorrectly, but the Argo has a 65,536 channel recording system for high density neural recording in vivo. So it's the capacity of its neural recording system is fantastic. So Paradromix also demonstrates an electrical recording from over 30,000 electrode channels in sheath cortex. It's the first product that will be a communication device for patients with severe paralysis. They're hoping to scale it for clinical use as early as 2023. Moving on to another tech innovation in August. It's called the Neurallink. So the Neurallink demonstrated their product in pigs in August. So Joyce, again, so far they've only, at least to our knowledge, have done it in one patient, three patients, Joyce, Dorothy, and Gertrude. So Joyce never had a neural implant. Dorothy, the pig that formerly, Dorothy is a pig that formerly had a neural implant and that was later removed. And Gertrude, the pig, was implanted with Link. So Link, it has 1024 channels. It's 23 by 8 millimeters. It's wireless and it charges using induction. And it's minimally invasive. It uses minimally invasive mechanized surgical implantation. And after implantation, two of the pigs had undergone surgery, and after implantation, their health shows that the implanted link as well as condition after removal is not affected drastically. So one of the pigs with implanted limb sensors was made to walk on a treadmill. The team then traced the limb functions to the brain activity read by Link. This result shows great consistency between the predicted and actual outputs. In addition to Neurallink, we also see the emergence of wearable imaging cap later in November. So this technology is developed by UCL, Cambridge University, the Rosie Hospital, and Gora Labs Ltd in collaboration. So they use high density diffuse optical tomography. This technology is harmless, uses harmless levels of red and near infrared light that's delivered via a variable cap to generate detailed 3D images of baby's brain activity. So it's great because it allows doctors and neuroscientists to image a baby's brain without needing an MRI, and it's kind of hard to get babies to sit still. So I think it's pretty great. It also allows the researchers and the doctors to do that while the baby is awake. And the LEDs and optical detectors of this device are arranged in a dense network over the scalp, as you can see, to map changes in oxygenation in the brain. These changes in oxygenation show the areas of brain that are busy processing information, meaning the team were able to create high-quality 3D images of baby brain activity for the first time outside an MRI scanner. That's it. That's pretty much it for technological innovations for this year. And I'll be now passing on to our next presenter.
Hey, everybody. My name's Nick Halper. This is actually Salt Lake City's first event. So I think this is the first time meeting our meetup group. So I guess, hey, everybody. We also have another one of the organizers and founders of the Salt Lake City chapter here in the presenters chat with us. You can see him tagged with the SLC tag. That's Landon. So excited to meet all of you. I guess for that reason, I'll give you a quick little introduction to myself. So as mentioned, my name's Nick. I'm actually a cellular neuroscientist by training, but started at BlackRock Microsystems as an engineer and kind of worked my way into product strategy there before starting my own company recently called BrainGrade. BrainGrade is a kind of super group. It's me and a few of the Neuralink founders and Paradromix founders got together and started a company to work on neuromodulation for Alzheimer's disease. So deep brain implants and a really, really cool team. So I'm super excited to be part of that. And if you're interested in kind of what we're doing, want to hear more about that, you can just Google me or BrainGrade and follow us either on our website or on LinkedIn. It's kind of where I hang out. So I'm going to be talking to you guys about regulatory approvals today, which most people hate. Or like regulatory is not like an exciting thing to talk about, but I think it's super interesting. because it represents the kind of like movement from some of this technology from like lab work and concept into actually being used by humans in like a medical and restorative context, which is what I'm all about. My mom is an amputee, so seeing these cool like BCI movement prostheses are like what I'm here for. So yeah, before we jump into regulatory, I just wanted to tell you guys a little bit, I guess, about some of the terminology I'm going to use during this, because it's kind of confusing when you hear it. So this year, for example, you might have heard that Neuralink got breakthrough device designation, and then you might have tried to look for the sign-up list to get implanted next week, but that's not the case. Breakthrough device designation is just a program that lets people notify the FDA that they have a new device that may be better than current therapies on the market. And if the FDA agrees with that, then they basically set your project on a fast track. So they take all the FDA like correspondence times and they cut them in half. That's basically what breakthrough device designation means. I mean, don't get me wrong, it's a cool thing, but it doesn't mean anything about it being closer to being done for regulatory approval. So the other actual regulatory approvals we'll talk about are IDEs. So these are investigational device exemptions. These are basically permissions to perform clinical trials. So we'll see a few of these pop up as we go through this. We'll also see three other types, 510Ks. 510Ks are a type of FDA clearance that basically means you got approval for your device because it's similar to another device on the market. Then you have FDA clearance and FDA approval, which are both just clearance to market, usually for brand new types of devices. So those are usually really exciting things to see hit, and they take a long time to get. So let's go ahead and hit some of these. So I'm just going to make sure I have the chat pulled up in case anybody asks anything. So the first device we're going to be talking about is the Neuroelectrics. So Neuroelectrics got an IDE approval. So they got approved for take-home use, which is actually super exciting. The indication here is for depression. When I was younger, I actually used to suffer from pretty severe depression. So this is like a really interesting concept to me. Maybe that's too personal, but whatever, we're here. So this device got approved for take-home use, which is obviously super exciting during this COVID pandemic time, because it means patients can actually take home a stimulation device, use it with a therapist over Zoom or something like that, and get treatment for depression with a neurostimulator at home. And that really breaks the ground on other types of advanced neurostimulators to be used at home for other psychological disorders. So this is an awesome breakthrough, not just for Neuroelectrics, but I think for the field in general. One of the next ones that's pretty interesting is the Achille, I think is how you pronounce it. This is actually the first prescription treatment to be delivered through a video game. And specifically, it's been cleared here for ADHD. So this is an actual clearance, like this is going to market, you can buy this. And it addresses the kind of attentional aspects of children with ADHD, or I guess it could theoretically be used on adults, but it's marketed and geared towards children. And it helps kind of tune those attentional networks better. And so it's that kind of like practice and use of this video game addresses the effects or basically symptoms of ADHD through practice and control, which is awesome, obviously an awesome breakthrough and kind of interesting to hear. First of its kind. So maybe we'll see more video games in the future that help with depression or anxiety or other kind of like psychological disorders. Another one that I saw this year that I'm super excited about, because this is kind of in my realm, is the Medtronic Percept. It's kind of a funny one, I think, because a lot of people see this like, they look at Medtronic, they look at deep brain stimulators, and they're like, oh, cool, like neurotechnology, med device, Medtronic's a huge company. The Percept is actually the first Medtronic device to be released with brain sensing technology, or her first DBS device with brain sensing technology. So up to this point, every deep brain stimulator kind of acted like a pacemaker. It stimulated into the brain, but it didn't check on what the brain status was to see if it was the right time to stimulate or whether it would be most beneficial now. So this one actually allows sensing, which is useful both for making the device more power efficient. It means the device can only stimulate, they can choose to stimulate when it's actually going to be needed or be effective. And it can also make it even more effective because it can choose to stimulate at the right times that the brain's needing it or expecting it to make the therapy more effective for typical deep brain indications, which are like things like Parkinson's disease. So this will open up those avenues to make these devices more effective for patients that currently have them, but it'll also make Medtronic to be able to allow them to be able to learn a bit more about how the device is working and how it's working for patients, and kind of optimize these therapies for future patients as well. So this is definitely exciting news. Kind of along those same lines and throwing it back to Medtronic a little bit, while Medtronic advanced their implant to have sensing technology, ABBOTT instead was kind of working on this patient user experience front. And so ABBOTT released their first iOS compatible app, so you can just get it on your normal smartphone to communicate with and manage your neural implants and other implants that they actually use, so other neurostimulators such as spinal cord stimulators and things like that. So I guess they beat Neuralink to the punch here a little bit. ABBOTT is the first iOS smartphone to control your actual implanted neurostimulator, which is pretty sweet for them. It's a good job to ABBOTT. The next one we see here is Brainways. So this is an actual additional clearance. So this is transcranial magnetic stimulation to be used for addiction. And this is a nice breakthrough. It follows the typical pattern of companies who will get clearance for one indication and then start adding additional indications onto it. And we're seeing a lot more of that for TMS. So this is obviously a really exciting one for that reason, and is the first clearance of addiction for any TMS device. So also a breakthrough for them. And the fact that it can be on market in as early as 2021 is also a really cool rollout plan. It helps that a lot of I guess clinics already have these devices in stock, because normally a company bringing things to market after clearance takes a long time. So this is a great way to kind of speed that process up as well when companies follow this pattern of regulatory approval. Another regulatory approval that came in is an IDE for take-home use of the Luke prosthetic arm. And I definitely encourage you guys to ask Landon about that a bit more, because he's been heavily involved in this. But as Salt Lake City residents and citizen of Utah, is that the right way to put it? Resident of Utah myself, this is obviously super exciting to me. Previously working at BlackRock, this uses the Utah Slant Array, and it also uses co-engineering by Ripple, another company here in Salt Lake City that Landon will speak on a little bit later today. So big collaboration between those two companies, as well as the University of Utah. So this is awesome stuff. I guess one kind of point to make on this slide, there's no actual company mentioned here, even though I just mentioned both BlackRock and Ripple, and that's because the IDEs can also be given to academic institutions. So in this case, Greg Clark and the team at University of Utah is the one who got this clinical trial. And even though these companies are hugely helpful in scoring those clinical trials and letting those academics take these products, to the home, this is actually to the academic institution. This one is also near and dear to my heart, even though they're technically a competitor of my new company. But this is the first ever treatment that's been shown to reverse Alzheimer's disease, and it's using a non-invasive stimulation method. So NeuroEm announced a breakthrough device designation this year, which obviously is a really cool designation. But I think even more interesting than that is that designation was based on the IDE that they got, I guess, late last year. And that IDE let patients take this device home and perform stimulation at home. And NeuroEm showed in rodents over the past few years that they can actually reverse some of the amyloid beta plaques and other actual, I guess you'd say, results or co-indicators of Alzheimer's disease, as well as reduce the symptoms of Alzheimer's disease in mice. And then they tried it in humans, and they're seeing the same effect. Now, they're not slicing humans' brains open, so they don't know whether it's working on the plaques very well. But they are seeing reduction in serum concentrations and other things like that. So this thing is definitely deserves breakthrough device status, because if it works, it could be an actual physical cure to Alzheimer's disease, which would be amazing. And the last one that I'll talk about here, I guess with slides, is the GE ultra high resolution scanner. So this is the first 7 Tesla MRI scanner with FDA clearance, which is a really nice breakthrough just in general for surgeons because they can see things at a much higher resolution, which should enable better and more accurate neurosurgeries, better localization of electrodes, because right now we're like locked to this kind of like 2 mm accuracy, and this is one of the things needed to break that. This is also going to help advance some of the like microstructure and research-based aspects of it as well. With that, I guess I also wanted to mention a couple other interesting ones this year. I mentioned Neuralink's breakthrough device designation. I also have a friend's company, Spark Biomedical, who got approval for their Sparrow neurostimulator this year. And that's actually a device that you attach to babies that helps them through opioid withdrawal. So when babies are born to mothers addicted to opioids, the babies are also addicted to opioids. And this device helps those babies with those withdrawal symptoms, which I think is incredible. Obviously, really good humanitarian work there as well. So those are two other ones that I particularly enjoyed. On the funding front, a ton of activity this year. Normally, we would have expected funding to really slow down with pandemics, but I think we actually saw more activity in neurotech funding and acquisitions this year than any other year. And I'm going to start off with the first one, which is community. So Kickstarters actually supported a whole bunch of cool brain projects this year. First was the Make 100. So this was a create your own brain-computer interface. This allowed creators to get this device, get a cool API up and going, and basically integrate it into their own apps, whether they wanted to use it as a speller or a joystick control, all sorts of different options for this kind of like do-it-yourself brain-computer interface. Another one that I saw that was pretty cool, I don't know if any of you are like Valorant players or, I don't know, whatever, Counter-Strike, wherever this really benefits from. But Brink Bionics released an Impulse neurocontroller for gaming. So it's basically a glove that you wear, and it detects basically your intention or kind of the very beginnings of starting to click. So you don't actually have to complete the whole finger movement before it registers a click on your computer. So you reduce your like input time by 80 milliseconds, which for a lot of people is like, you're into like negative ping now or something compared to other gamers. So that's a pretty cool one. And then HatBee was another device that received a lot of attention. This is a I guess choose your own emotion I guess neurostimulator. At least that's what they claim. So supposedly you can like program it in here and say, oh, I want to be sleepy now, or I want to be happy now, or I want to feel content now. And so as these devices start shipping, I'm interested to hear how people are experiencing them. Another company that I think is really interesting, we call them a neurotech company, and they're the neurotech adjacent. Rune Labs. I'm not sure if Brian's here in the participants. He said he might come tonight. So Brian Pepin has a really long kind of illustrious career, and he recently started a company called Rune Labs. And Rune Labs is kind of like I want to call them the Dropbox for neuromodulation data. So basically they work with other big companies that generate neuromodulation data, let's say Medtronic or NeuroPace, or even smaller companies that generate neuromodulation data like BlackRock Microsystems. And those companies can dump the data into Rune Labs like servers through their API. So if you have a patient app like Abbott's Neurosphere, or you're working with a set of researchers, they can dump data into this, and you can set up your own kind of like data pre-processing routines, I guess I'll call them. So that data can be like organized or like looked at in a certain way. And then these researchers at these companies can come collect that data and use it to, learn about their devices, improve their devices, and kind of like make judgments of effectiveness and things like that. So it's a really cool way to kind of provide cloud services to the neuromodulation and neurotech communities. So all sorts of cool ways to use this. And it's probably a company that I'll end up using in the future for my company. So I'm sure I'll see a partnership coming on here. But they because of this awesome concept, they closed a $5 million seed round this year for I think it's a team of about 10 to 12 people. So that's going to be awesome for them. Another company, or I should say this is kind of a funding thing, but it's an acquisition. So Magstem, which is a company that's traditionally worked on transcranial magnetic stimulation, actually acquired electrical geodesics. So EGI is what they're called. EGI is a company that makes neural nets, high density ones. In fact, this is the one that I used when I started my EEG lab at my school, Westminster, here in Salt Lake City. And so basically what Magstem is trying to do is like round out their product portfolio. So they normally make transcranial magnetic stimulation. And in this case, they can actually start focusing on using these EEG headsets, both for acquisition, but also stimulation. And so they're looking to make some non-invasive neuromodulation therapies using these high density nets, which I think is a pretty cool way to round it out. And I think one of the last ones that I guess second to last ones that I'll talk about, Neuroviolence basically got a new funding round to establish speeding up their clinical trials. So for those of you who haven't worked with clinical trials too much, basically the more money you pump into them, the faster they can happen, at least to some extent, because you can run more of them in parallel. And for a non-invasive device like this, it's mostly about securing new sites that can like run this in parallel and gather kind of information and results at the same time. So this $5 million funding is going to drastically speed up this time to market for this device. Another awesome funding that happened this year is Therapeutics. So Therapeutics raised another 1.5 million to finalize the design of their device for storing memory. And this is actually a really interesting company to me because I worked with them from the very beginning. Therapeutics came out of DARPA RAM, which was a program from DARPA to restore active memory. That's what the acronym stands for. And this Pennsylvania group had like 6 or 7 sites around the US. And I was involved with them to train the different sites and get them set up on the stimulation system. So I definitely have a lot of support for this company, being involved with them so closely. And basically what this $1.5 million is going to do is going to help take them from kind of they have the science done, right? They did that big trial for the DARPA RAM project, but now they need to turn it into an actual implantable device instead of some of the prototype devices they had. So this $1.5 million is going to help them finalize that, which will be a really good touch to the acquisition that they did last year, which was of Cortera's neurotechnology and intellectual property platform, which was basically the stimulation electronics inside their device. So this final push should get them to the beginning of their kind of next clinical trial, which is going to be awesome. And then I guess this is probably the biggest acquisition or kind of transfer of money, I think, in neurotech this year, at least by my measures. So Astellas is a Japanese, I think it's Japanese investment firm that originally had sponsored or funded this company called Iota Biosciences. And Iota Biosciences was originally taking part in this other DARPA competition or called NESD BISC. Or no, that's not the right one. Yeah, NESD, which was basically for large channel count broadly spread systems. And Iota Biosciences basically pitched this concept of neural dust. You can see them in the picture here, these tiny little granule-sized neurostimulators. And these both record and stimulate, and they're powered through ultrasound. And Astellas originally invested in this company several years ago. And this year they decided to go all in. So they acquired the rest of the shares of the company for $150 million, paid out an additional $150 million to all of the shareholders, and then committed over the next 3 years another $150 million at minimum. And they're going to use this to accelerate engineering development of these devices and then eventual clinical trials. And if it works, these are going to be really awesome. These are long-term chronic implants that can be used for all sorts of different neurostimulation activities. So if you need to stimulate deep brain structures with these, you can deliver them there. If you need to dump them into peripheral nerves, you can deliver them there. The platform itself is really flexible if they can get the engineering done for this neural dust. So I'm going to pass it on to Morgan to let you guys hear more about the competition results. And again, if you want to connect, feel free to reach out to me on LinkedIn or here in chat, and happy to talk.
Thanks so much, Nick.
Yep.
And let me share my screen. All right, terrific. So now we're going to move on to some of the competition results from this year. And in particular, I mean, this first competition that was run this year, or 2020, I should say, last year, was the Neureka Epilepsy Challenge. And, this particular challenge also, truly combines kind of like the community, the education and the innovation, in the sense that it provided an opportunity for anyone who was interested and had the kind of the computational resources to take on this data set. It's a big one. As you can see, so this is the Temple University Hospital epilepsy corpus, in particular the seizure data set. And like you could see here, it's got close to 1,000 subjects, or 700 subjects, hours of recordings, and it was scored with a particular program looking at both specificity and sensitivity, as well as looking at your ability to improve on the kind of efficiency of the channels that you used, in terms of, could you subsample the data and still maintain a very high sensitivity and specificity. So the first and second place winners, Biomedical Regulars and NeuroSid, first place used 16 of the 20 channels, and NeuroSid used 3. And yeah, there was a lot to be learned from it. For myself, this is a data set that's been used in a number of recent research projects, a number of deep learning projects, looking at things like brain age from the EEG itself. And you can, I think there's even more to be mined from this. And we're looking forward to trying to help the community after this project. We really wanted to see the ability to give people additional resources to take on a challenge like this. So I'd also just want to point out the IEEE SPMB Signal Processing and Medicine and Biology conference that was, I believe, in November of last year, perhaps the beginning of December, where the results of this were presented, and I believe the proceedings of that will be out in a couple months. And also check the website for, and this is to my point about improving on this competition. Perhaps for this year, you should also be able to find GitHub links to these winners, and in the IEEE SPMB proceedings, there's also links to previous pipelines that have looked at this particular seizure problem. For instance, like the IBM pipeline from 2019. So this is not a competition or contest that we're running, but definitely I think one of the more unique devices and of 2020. This is a contest run by Neosensory. And so Neosensory is a wristband that allows you to experience sound as touch and gain new awareness. So perhaps more directed at people with hearing disorders, but this is also a super interesting platform where they've run a number of, I think there's now a second competition going on currently together with Hackster.io and Edge Impulse. So they're really opening this up in terms of allowing people to connect other sensors to, instead of just sound, and to turn those into a touch experience. And so you see here with this Buzz Arduino air quality sensor, was the winner of the fall competition, and I believe the current competition just finished up perhaps last week. I do believe that Jenny is one of the developer relations people from Neosensory has joined us, and I hope she can stay for GatherTown and you can ask questions about that. So I also, I mean, we had Mike Parada on from Neosensory to talk about this. We love this as potential stimulation device for EEG, and so I really look forward to hearing about additional uses of this. And I love also what they've done with Hackster in terms of, this will feed into some of the discussions that you'll see later about open neuro hardware. Okay, the annual student club competition, and I'm not exactly sure, but I believe this is almost 4 years now. Certainly multiple years that this has been going on, and again, it's another great competition, definitely focused on the education, but there's two challenges. So the open challenge and the fixed challenge. And the open challenge is putting an emphasis on the kind of creativity of the project, and the fixed challenge is more on the depth and breadth of the technical demonstration. So yeah, I think there's, well, I mean, I think there's a lot to see. Go to the Neuro Club, the Student Club archive, and check out the presentations that the student clubs. I'm not going to be able to do them as much justice as their own videos and other demonstrations. I love this competition though for what it's accomplished, and I hope that we also use the previous competition winners and projects to again feed back into improving the resources for the community for next year's competition. So the one of the companies this year that did a call for projects with offering grants up to 150,000 euros was BitBrain, and so this is actually starting last week in terms of the projects that got funded. In addition to BitBrain equipment, which is a wireless EEG system from Spain, there are you could also include eye tracking equipment from Tobii, and I believe behavioral software, as well as psychology software tools and their ePrime experimental control system. Although PSD also makes fMRI hardware devices and some other things. So I don't know if they've actually, I assume all these projects have been announced at this point if they've got these kickoff meetings, but I really look forward to seeing what comes out of this work. And then the Cybathlon 2020, this is the Bionic Olympics, and ETH Zurich hosted. It was, post COVID, so it was slightly different than other years, but again, like the quality of this competition is just outstanding. The engineering quality of this competition is outstanding. So there's more than 50 teams from all over the world. It's a really unique set of challenges, that is pushing, as you can see, brain-computer interfaces, exoskeletons, prosthesis, of all sorts, and of course the powered wheelchairs. And really, you've got to dig into the site to see all the challenges that the operators and pilots of this equipment are facing. It is a remarkable event. So finishing up, we're going to just go over the NTX community efforts. And I wanted to just highlight the weekly hack nights that we have been doing together with, so San Francisco has been doing a weekly hack night together with Toronto since COVID started, and I believe we're going to continue to do this. Paris, as we've also, Paris's NeuroTechX chapter actually started or was an outgrowth of CogLab that predated NeuroTechX. But I'm also part of, I co-host the Paris meetup, weekly meetup. And this is a real opportunity each week to come ask questions, hear about other members' projects, and potentially hear from invited speakers. And when new equipment comes out or new interesting applications, they are everyone. Please let me know if you know of interested speakers. We're always on the lookout, as well as the fact that would love to help other groups potentially, and especially in Asia at this point, in terms of covering more time zones, help other groups get to have this, and again, use it as an opportunity to build the community. So we've also been trying to start some weekly groups in terms of neurorobotics, and we're going to be starting neuroimaging one soon. And as I'll discuss a little later, we've got developer meetings on some of the NeuroTechX projects like MOAB. We'll be starting soon on EEG notebooks, and the kind of coalesce some of the open hardware projects that we have been working on into a weekly meeting too. So find those on Slack. The NeuroTechX Diversity Initiative is one of the community-led initiatives that started this year as an outgrowth of the movement for racial justice that started here in the States, but really spread globally. And we stepped back and wanted to have a discussion and wanted to make this into a community initiative about, even though NeuroTechX is an open community, what else can we do to tackle these issues of systemic racism and make the community more inclusive in a kind of proactive fashion. So we've split the initiative into two groups: the Diversity Committee and the Diversity Consortium. You can find us again on Slack. We're still, get in touch with Abby Holland or Maria on Slack in terms of, I believe they're still looking. I mean, you can still apply for positions on some of these, as well as get in touch about, some of the actions that we're going to be taking, starting this year. Right. So there's two main pushes that we've really made this year, and it's been great to see what's happened. But EEG notebooks is a project that grew out of Alexander Barachon and probably others' effort called Muse LSL. So this was an early project of getting raw data into an LSL stream and also having basic tools in Python. But EEG notebooks has really matured into a much more comprehensive set of event-related potential research tools, right? In terms of both acquisition as experimental control and to some degree analysis and visualization. So this is a library that's built on M&E, PsychoPy for all the experimental control, the standard computational Python libraries, and what has so John Griffiths leads that as a chapter lead in Toronto, as well as a professor at University of Toronto. He's maintaining the GitHub and running that particular group. Jaden Tredup added something that was actually a Andrei Parfenov project, BrainFlow, but which gave this EEG notebooks the ability to support many more devices, as you can see listed there. So this is what the kind of latest version that is, as it says, democratizing the cognitive neuroscience experiment, is that Jaden's added the ability to support many more consumer grade devices at a price point that makes these more affordable. And we're trying to bring down that price point as best we can, and trying to keep the tool set as kind of easy to use as the Muse was. So in addition, there's lots of people that have made contributions, and please check out the GitHub link, check out the discussions that are taking place there. Really trying to use GitHub as much as possible in that. So I also want to, again, this isn't a NeuroTechX project, but BrainFlow has made such a difference in EEG notebooks, and this is an API that Andrei Parfenov developed. It's in Moscow. He's got check out brainflow.org. It's got some wonderful examples. This is used not only by OpenBCI GUI, it's used by MindEffect, it's used by TimeFlux. These are kind of real-time EEG packages, and M&E Scan, which is part of M&E CPP. Check out the GitHub. Again, like it's a wonderful package that's being used in more and more tools. We're seeing, just someone today pointed me to another wonderful BrainFlow hack. And he also maintains his own Slack. The mother of all BCI benchmarks was another Alexander Barashon project. I was on I remember many years ago when he had the first call kind of initiating this project. And, I was so amazed that this hadn't already been done. But, what he was tackling at the time, and it's really in so many ways hasn't changed today, but is the unreproducible research in BCI, right? How many times have you seen a new paper pop up in archive, and in terms of machine learning in BCI, but the code is unavailable. It's using some inaccessible, data format or toolbox, or, something that doesn't allow you to reproduce the pipeline itself. It's unclear how the data was pre-processed, and, what kind of automated or manual artifact correction has taken place. And then, finally, how often are you seeing kind of, these kind of straw man like comparisons, and being unsure of how well this truly reflects an improvement and over other, what let's call state-of-the-art algorithms. So what MOAB is attempting to do is become a publicly available standardized benchmark for BCI research. And, it seems strange that we even still have to say this, that obviously this is what, the community should be pushing for. And, today it already has, 10 plus data sets with motor imagery, as well as examples of P300 SSVEPs, primarily in kind of, typical BCI experimental paradigms. But we're adding more, and I think there's actually something to be said for doing this with some more conventional paradigms. But it's been terrific to talk to people that are developing new analysis pipelines and coming off of their master's or their PhD and saying, I wish I had seen Moab when I got started, in the sense that like, I would, everybody would much prefer to be testing their algorithm against, more than 2 data sets. And they would certainly like to see the performance of their algorithm against more than, say, 6 pipelines. So we're pushing to add more pipelines. We're pushing to add more data sets. Please check the GitHub on this. And there's documentation. We've started using Gitter for to track the developer discussion. And this is one of the examples where we just had a developer meeting today. So you can catch us at the Thursday at 6:30 European time, Central European time. That's 9:30 a.m. and West Coast. So lots of people to thank here. Alexander Barachon is on the top there. Vinay is anti-clockwise, and then Sylvain Chevalier, who's currently maintaining the GitHub project, as well as running the developer meetings. Lots of other people are contributing, and it's great to see this. Great to see this growing. So another community-led initiative is the Content Laboratory, and this is another. This is something that got started last year, but we're really waiting. This year we're going to see some of the fruits of that work. So I know this is being led by Adam Molnar at Neurable, Shamay Agaron, and Sophie Valentine at NTX London. Combining people with writing experience and design, and as well as targeting, I don't want to say marketing, but knowing what topics people are looking to hear from, and allowing those to be developed. So some of these publications are issues that you'd guess in terms of focusing on some Neurallink and things. Excuse me. As well as some are following some of the design initiatives, for instance, for us, who's putting together his own set of speakers. So really looking forward to hearing more about this from the Content Laboratory this year. And yeah, so you can, here's just an overview. I mean, there's just way too many community efforts and events this year. We could have, the NTX BCI 101 itself and NTX Neurogaming were both incredible events that would, could take up the entire meeting today. In addition, it's been terrific to see what new chapters are bringing in terms of their interests and their experience with, DC with new brain science. NeuroTechX India has had a wonderful set of topics, and as Berlin, and you can see the Neurotech design series that Barcelona and for us started neuroethics in Zurich, and Galicia has brought in something among the neuroscience in cinema. There's so much to get from the additional chapters in terms of directions. It's been wonderful to see, and BCI Samara was a partner event with NeuroTechX, as well as NeuroTechX Alberta and NeuroNexus, which was really wonderful. kind of startup experience for undergrads there that I got to participate in. Incredible stuff being led by the community here. So just got a couple extra things that want to talk about. This particular collaboration, or this BlackRock Microsystems licensing Weiss Center's real-time neural signal processing platform. I certainly want to see, or we're talking already about an initiative at NeuroTechX to increase our educational content and our tutorials on invasive electrophysiology. Things like the Neurodata Without Borders, Dandy Archive, making accessible a lot of the work from the Brain Initiative, and part of the Neurodata Without Borders obviously is making the data sets compatible, but also what are the tools, and can we make those tools accessible for the community to compete even with commercial products. So one thing that I mentioned earlier in terms of open hardware, it was very interesting to see Google X release their Project Amber EEG hardware and software. So this is near and dear to my heart in terms of a focus on depression. And just one second. Excuse me. Yeah, this is an example that we are working with NoiseBridge to look at the ability to take what Google X has open sourced here. I believe this is under Apache license, and make the EEG accessible, or make this particular hardware accessible. And this is also interesting in terms of the DeepMind collaboration that Google X had in terms of the machine learning. We're hoping to learn a lot from this, but it's making, this has been a real opportunity for us to learn how to incorporate some of this project into our own open neuro hardware resources. So like we've mentioned, this is a 5-year anniversary of NeuroTechX. The picture that you saw of people sitting around at Hacknight, that's a picture that was my first experience back 5 years ago in a garage here in San Francisco, together with the chapter leads at the time. And it was, it's been an incredible journey to watch this community grow over these years. So please stay in touch. You can find us on all the social media platforms. And if you aren't already signed up on Slack, please get in touch and we'll make sure you get a link. So at that, I'm going to ask if we are going to post the Gather Town, I believe.
Before we move on, I just kind of wanted to add a blurb out here for the NeuroTech Vancouver group. We are hoping to branch out and expand a lot more. It's been dead quiet here primarily because of the pandemic. So if anyone's interested in joining, we have a number of positions available. Please get in touch. I'm also open to listening to some ideas about what to do for the summer, because I'm planning an event. So do get in touch. Our emails was in the previous slides. You can also get in touch through Facebook or Twitter. Thanks.
Yeah. And please, if you're in a city that doesn't have an active chapter, please get in touch with us, and we would love to help you set one up, or join us certainly at Hacknight in a time zone near you, and we'd love to answer questions after this event as well.
So we're now going to be moving to the, I guess, next part of this event, which is networking, as well as some additional talks from some special speakers that we have. So we're hosting this on GatherTown, which is a kind of virtual conference service that lets you go up to people with a digital avatar and engage in conversation with them, because we feel like this will lead to better group conversations between some of the speakers you heard tonight, as well as the speakers you're about to hear in just a moment. So please do join us over there. We have some awesome presentations from Ripple and Plato Science, as well as others. So there should be a link posted here in chat. If it's not here right now, it'll be here in just a second. And everybody who's in here is welcome to join us there.
Thank you very much. Cool. I'm going to switch back to the placeholder, then come back on the
So Mohit just posted the
GatherTown.
link and password in chat. So please do come join us. It's going to be a great time over there. So I'm going to stay in this room a little bit until everybody's over there. We'll give it about 5 minutes for the transition before we start with our first speaker.
Mhm. I hope everyone liked that so far. Okay, it's going to be just a second. Need to change the input. Cool. Okay, and I'm switching back. Cool.
It's me. Hardware mutes. Hardware mutes.
Hello.
Yeah, I think I hope so. Seems like we have some pretty good engagement, pretty active chat. So I think this looks like it's filling up pretty well too. So, Balder, can you hear us? Yes, I can hear you.
Cool.
And soon, it looks like maybe soon I'll be able to see you. Yeah. Cool.
Cool. This looks interesting. lot of people in here. Cool. Presentations are working. This is pretty cool. Hmm. Not one in the lounge right now. Ah, cool. Exhibitor videos.
This interface myself.
There it is.
Looks like people are almost ready.
Okay, just testing that everybody here in the audience can hear me, making sure that AV is working. I see some thumbs up, so it sounds like that's a yes. I just wanted to take this time to introduce Balder from Plato Science. He's a friend of mine and also a really just generally awesome guy. For those of you who haven't seen his TED Talk on creativity, I highly suggest you watch it. I still use those creativity boosting tips like every night because I think they're just so helpful. He's going to show us some work by Plato Science and the headbands that they make, which are used not just for creativity, but learning enhancement as well. So I'm going to turn the podium over to him. I'm assuming the AV issues are worked out, and looking forward to hear from him.
Seems like there might. Oh, perfect. It's up and working.
Balder is figuring out some audio visual issues, and so we're going to actually hear from Landon next, who can jump on right now and present to us on Ripple.
To try and share my screen real quick. Are you guys seeing a PowerPoint at this point? Awesome. I'm seeing a thumbs up there. Cool. So I'm going to put this in this mode. Are you guys still, you got a full screen now, Nick? That looked like a shake of the head. I'll take it. Cool. Awesome. Thank you, everybody who decided to move over here from Zoom. I know this is kind of a new and interesting platform. I've actually used it a little bit myself, so that's why I might seem a little more keen on it. Thanks to all the chapters that put this together tonight. This was really cool, learning about so many new and interesting devices, technologies, developments in neurotechnology. My name is Landon Minch. I am one of the co-founders of the NeuroTechX SLC chapter. That's kind of my afternoon job. My day job, actually, though, is a research support engineer and neuroscience projects coordinator at Ripple LLC, which is what I will be talking about today after a brief little introduction to myself. So my interest in neural engineering started pretty much as early as high school. I was always fascinated by the intersection of science and technology. And that led me ultimately to pursue a degree in biomedical engineering from Indiana University, Purdue University, Indianapolis. It was a solid program, and they were offering to also pay my way through if I swam with them. So I gave that my all. During my junior year, I had an opportunity to do a research experience for undergrads at the Center for Sensory Motor Neural Engineering. Looks like I messed up that acronym there. But that recently changed, the Center for Neurotechnology, still located at the University of Washington, though. After that REU, I was fascinated by the brain. So I did a stint my senior year in a bioelectronics lab, which ultimately led me to a master's degree at the same institution. So I got my master's degree at Purdue University in a cardiovascular neurophysiology lab. The next slide, I'll talk a little bit about what my thesis work was there. But one of the really, really cool opportunities I had while I was there was working on a project with, or that was funded by, Galvani Bioelectronics. And we were looking at kind of novel stimulation paradigms for conduction block techniques in the in the autonomic nervous system. That work eventually led to a publication, which I was able to share at a conference, and led me to meet some of my now colleagues at Ripple, which I will get into after talking a little bit about my cool thesis in my master's degree. So I worked on understanding the afferent kind of language of the autonomic nervous system. To do this, I created an experimental model to artificially evoke the parasympathetic activation of the aortic baroreceptors. This is known as the baroreceptor response. And the model I used was a rat. So by electrically activating this specific nerve in the rat, you can create this really cool depressor response. And I was kind of looking at the difference in that response between males and females. Ultimately, what I found is the response is a bit different, but that the brain is a lot smarter than the heart. And this only led me down an even deeper rabbit hole to continue looking at neural engineering, which is why I'm at Ripple now today. So enough about me. Let's talk a little bit about Ripple. Many of you may know Ripple as a data acquisition hardware manufacturer. That's kind of what we're known as today, but we're a little over 15 years old now. Ripple kind of began in 2005. It was when it was founded and initially funded. We got that initial money through DARPA, the kind of revolutionizing prosthetics subcontract. During that subcontract, we were really trying to create a mobile acquisition machine that could, allow for a little more free-form acquisition of neural signals, and that's where we created this first neural interface processor here. That processor was eventually purchased in 2009, our first commercial sale by Doug Weber, at that time at the University of Pittsburgh. And that first processor is still actually out in the field today. We had to return it about a month and a half ago, and I got to play around with it, but it is still up and running, which is really cool. About 2 years after that first commercial sale, we started creating our sales and support team. So really trying to bolster that commercially viable product. And then a year later began working on the NIH IEMG project. This was really to create a fully implantable amplifier that did not have percutaneous leads. You didn't have to worry about, as much about biocompatibility. And you can kind of see a cool little prototype of one of those first devices we did here in the middle. That eventually led to the possibility of doing some more funding. We entered into the DARPA Haptics project in 2015 and continued to just create some really cool hardware out of that. Haptics ended in 2020, so we just wrapped that up. But now we've been lucky enough to join a couple other grants, HEAL, for instance, and Athena, to continue kind of that research side of Ripple. So that got us to where we kind of are today. So this is Ripple 2020 and beyond. We've decided to create several sister companies. I've outlined 4 of them here, which are focused on various stages of the device development lifecycle. You may be asking, what is the device development lifecycle? If you look at the bottom here, we've kind of broken it into 4 different groups. there's kind of raw science. So this is, the heavy lifting of academia researchers. There's translational research. So you're trying to take, a rat or a non-human primate model and make that applicable to humans. You're then going to develop or design some kind of device that is able to leverage that translational research and then ultimately create a clinical therapy or a medical device to, really help humans and humanity. So this is kind of what we consider the development pipeline, and we've kind of organized these companies into the different stages of that. The one you guys are probably most familiar with and that I work in a daily basis is Ripple Neuro and Ripple Neuromed. These are two companies that focus on neuroscience research tools. Ripple Neuro, you've probably heard of the Grapevine product line. We're really focused on animal research in this product line. We're one of the first to come up with the simultaneous stimulation and recording technology, which was and is super helpful if you are going to be doing both of those modalities. We also, through some of that early DARPA money, came up with some pretty revolutionary implantable technology that we're still innovating on to this day. And then one of my personal favorites that I get to interact with quite a bit as a research support engineer is our real-time APIs that allow for some pretty cool low latency closed loop applications. MATLAB, Python, they're all C-based, but really allow for some cool and intuitive and customizable experimental platforms. The other company in that space is Ripple Neuromed. This kind of spawned out of some non-invasive and human applications that we weren't fully realizing for a while. And in 2020, Ripple Neuromed really took off. We focus on invasive and non-invasive human research. So you can think EEG, SEEG, DBS, ECOG, you name it, we'll make it so that we can connect to your electrode. What kind of separates us from other people in this area is the small form factor and portability of our devices. Most EEG systems are pretty bulky. You have to have somebody sitting at a desk. You have to worry about, environmental noise. And the way our technology works, a lot of that is minimalized, and also the modular design. We have a number of clinical adapters. That one on the bottom right there is for the Natus system. So Natus system is a very common epilepsy monitoring unit device that we've basically made. Or we have not made, but we've created adapters that we can kind of tee off of that and still allow for some really cool data acquisition. And so you have an adapter, or you have an electrode system that you're interested in using, please contact our engineers. We'd be happy to work with you. This is not a sales pitch, though. I am here for neurotech over anything else. So science, we talked about raw science. Now, Iris Biomedical is kind of the next company I'm in a translational and device development space. We actually consider Iris Biomedical a contract engineering company that helps other entities, whether they be, commercial or other, design and develop neural interface devices. So Iris Biomedical, as I mentioned, manufactures medical device or helps with medical device design and development. The two biggest areas that we've really been growing in is neuroprosthetics and neural interface applications. Kind of the best example I can give you that was talked about a little bit earlier is Synchron. Synchron had this awesome Centroid technology that they wanted to use as a BCI, but they didn't really have kind of the rest of the pipeline there. And so we've helped them kind of get up to speed with acquisition. This is a acquisition and analysis. So this is a little visual from their recently published paper in the Journal of Neurointerventional Surgery. They have, this very cool Centroid electrode technology, and we're kind of this signal control unit and ETU and ITU. We've helped them develop and kind of bring out that technology. So a really cool collaboration, and hopefully we'll have more to share with you guys in the coming year. Iris is also working on developing some more innovative implantable technology. We're currently working on an implant capable of multi-channel closed loop stimulation and recording. So, it's one thing if you can do that wired, but if you can do that untethered, it kind of opens up a whole new world of potential closed loop applications for neurotechnology. And so this is something we're still kind of very early development as far as these designs here are concerned, but is again being seeded by Iris Biomedical and some of the grants we're working on. The next entity that I will cover, and kind of the final one, is the clinical therapy space. So Sync Bionics creates medical devices specifically for neuroprosthetics at this point. They're working to manufacture medical devices and assist patients with debilitating injury. This is one of kind of our early proof of concepts here. It's a feasibility trial where we showed the ability to monitor the gait of dogs in real time. This can be really useful for harnessing, residual muscles or neural pathways following injury. I'll take you to the next slide where we actually have an example of a non-invasive application of this technology using other kind of core technology of Ripple's to manipulate a robotic arm. You could easily imagine this same kind of output being an implantable EMG recording unit, which is what Greg Clark here on the right side is trying to do with one of his IRBs right now that Nick was talking about a little earlier. And then we have kind of a awesome tweet that Ripple loves to brag about and highlight with Mark Hamill, aka Luke Skywalker, given a pretty surreal endorsement for Ripple and Sync Bionics technology that Greg is using to move forward. So that's kind of the 500-foot view of these different companies and how they're working. The Ripple umbrella here is and continues to grow to address the different markets in neurotechnology. We're super excited to touch these different areas of neuroscience and neurotechnology development, and only want to see all of this that neurotech and the rest of the community is interested in continue to grow. So I thank you for your time. These are a couple contacts you can use to get in contact with me or Nick with the chapter. That's kind of my personal email. So I appreciate your guys' time, and I'm happy to answer some questions if we have them after our next presenter. Thanks.
For the people watching the stream, I'm sorry it seems to have a video desync error right now. But I am recording this separately and will be putting the recording up after the vent on the Noise Bridge YouTube. Also, for people watching this stream, if you haven't heard of this is called Gather Town. It's a pretty fun little system that allows for presentations and meeting spaces.
Hey guys, it's Landon again. We're working out a couple little kinks with the next speaker. Appreciate your patience while we get them all queued up. Thank you guys.
So, hi everyone. I'm going to introduce the next speaker for this evening, which is John Griffiths, who is a scientist at the Kremble Center for Neuroinformatics, which is the Center for Addiction and Mental Health, as well as being assistant professor at University of Toronto. And in addition to all of those things, is also the co-chapter lead at NeuroTechX Toronto, and a big part of what makes Neurotech San Francisco Hacknight's been such an awesome year. Yeah, I've met John at Computational Neurosciences and have enjoyed the conversation since. So one of the big initiatives that John has been leading here at NeuroTechX is the EEG notebooks. And I'm going to turn it over to John to tell you about not only the state of the project, but the long-term goals and the many initiatives or collaborations that John is leading with groups like OpenBCI, amongst others.
Okay, hi everyone. I'm going to share my slides and let's kick off. Is this broadcasting okay, Mohit? Yeah, Morgan, thumbs up there. Okay, great. Hi everyone. Thank you very much for the intro, Morgan. Appreciate that. And right back at you. The San Francisco Hacknights have been an intellectual pleasure and a lot of fun as well. And I definitely encourage people who haven't dropped in from time to time to do so as often as you like. But there's a lot of interesting discussions and interesting people kind of moving through that space. So what I want to do here is give a compressed version of a talk that I gave at BrainHack Ontario just a few weeks ago. Well, in December it was. So it was about an hour, the original talk, but I'm going to try and do this in about 10 minutes. So there'll be a lot of whizzing through slides, which, if you can deal with that, then that if you'll indulge me in that, and then you won't have to sit here for an hour, so which you don't want to be doing. But yeah, so Morgan highlighted, or he commented on this image that I put together when I was thinking about how to kind of describe this project, and it really speaks to what it is that, for me, one of the chief motivations of this tool, which I'll talk to you more about, EEG notebooks, which is democratizing the cognitive neuroscience experiment, and I'll come back to this figure in a second, actually. So let me just tell you, I'll go into two things. I'll tell you a little bit about what are like the motivations for what it is that we're trying to do, and then I'll touch a little bit on some of the technical aspects of the library that we've developed, and then we can take it from there with Q&A, and a bit of back and forth. So the motivation really is on the first hand, why do we want to do EEG? I don't want to go into the full background here, but I think there's a lot of people who are here know, like, this is a useful tool for measuring brain activity. It has a lot of good properties like temporal resolution and lightweight. It has some direct applications in clinical practice and emerging applications in things like BCIs. So it's a very flexible, important technology. The key contrast that I want to emphasize here is research versus consumer grade EEG, and the emphasis with the NeuroTechX community is very much towards the consumer grade side of things. But it's still worth emphasizing, that in the case of your kind of standard or traditional research setup, you're talking about fairly high price points, right? So kind of I have these in Canadian numbers, but I say just in terms of your standard devices, like on the order of going up to 3-figure numbers just to get hardware and to set up an EEG lab, right? So it's not just an EEG device, but you need like a room, you need additional stuff like screens or laptops, personnel. Often that's your standard research EEG setup. In the consumer case, depending on the exact device you're using, we're looking at aiming for things that are generally under $1,000. So big difference there, and the price point difference really enables a lot. So that's a big motivation for consumer grade EEG. So as I said, what are we interested in doing with this project? We're interested in, as I said, democratizing the cognitive neuroscience experiment. And what I mean by that specifically is what I mean by that specifically is actually, I'm sorry, I'm kind of thinking about how to compress this talk, and I'm kind of losing my thread for a second. So I'm going to just skip through to here and then kind of reset a second. So what we've developed is a tool. It's come over a number of years from a few different contributors. As Morgan mentioned in the talk earlier on, it really came through originally from ideas from Alexandre Barachon, and then we just kind of took the bow plan that he laid down and kind of built it out. But it's a Python-based library that lets you run cognitive neuroscience experiments using mobile EEG devices on a standard laptop. And what we're aiming to do here is basically give people who want to do the type of experiments and cognitive paradigms that have typically been done in a standard EEG lab, like a university or hospital-based EEG lab, allow you to run those kind of experiments and do that kind of research on a laptop with a low-cost device. So that's the objective of the project. There are some related projects on the go that, and there are more than what I've listed here, but EEG EDU, Carl Matheson's project, deserves a mention, and that's doing a similar type of thing, but fully browser-based, so with some kind of different back-end, but similar objectives. And companies, outfits like Mind Effect are doing, there's some overlap in terms of some of the, say, visual experiments on. So there are related projects going on more than just these two. But what we're aiming for, particularly with this project, and I guess this is the key thing to emphasize really, is what we're aiming to be the go-to open source scientific library and kind of community project for doing time-locked, and I kind of emphasize this, time-locked cognitive neuroscience and brain-computer interface mobile EEG experiments. Okay, we're also working on developing open access data sets and working on a kind of model for having community contributions from around the world to try and build out a database for mobile EEG data using these kind of paradigms, and we're interested in capitalizing on these aspects of the setup that I just described, as in using low-cost devices and doing stuff on a standard laptop. What that allows us to do is to do new things in a number of different spaces. So we're interested in doing new things in terms of research, in clinical spaces, in education, both, let's say, university and also high school. We've done some work in high school, and just broadly in the interest, enthusiast hacker communities as well. All these areas we think can stand to benefit from having a decent, high quality piece of open source software that allows you to fairly easy, fairly painlessly run some of these experiments that have been developed over the last few decades. Some of them have been really honed, and they continue to be, a lot of work going into understanding how the brain works in a number of ways, and also a space for developing new things. So one of the things that we're also we want to kind of facilitate is like a lightweight implementation of new experimental paradigms and new cognitive tasks and allow, if you like, kind of quick turnover of trying out new things. So all these things are going to be things we're aiming to facilitate with this software tool. I talked a little bit about the history there, but just one or two quick words before I wrap up on the nuts and bolts. So what EEG Notebooks is doing, it's really three things. And, honestly, and I don't have any qualms with saying this, we're not trying to, we're not claiming to be doing massive innovation on any given one of these. What we're really doing, the kind of USP of the project is being a certain kind of glue for a few critical components that are necessary for doing the things that we want to do. And the things that we want to do, or the components that need to be there, are engaging a data stream from an EEG device, delivering some stimulus, some stimuli in the form of a cognitive task with a particular temporal experimental design, whether it's visual images or sounds or some behavioral response task, and then pulling those two things together, getting them written to file, and then analyzing data and having some off-the-shelf tools there to let you kind of quickly move into getting some insight and some interesting results from those data. Okay, so the key thing with the library is really just pulling together available tools, particularly the ones I've listed here: Muse, LSL, and Brainflow for the streaming, PsychoPy for the experiment design, and then MNE, and then the broader scientific Python ecosystem for data analysis and organization. Just pulling those together in a convenient way. That's what EEG Notebooks is in a nutshell. We, as Morgan mentioned in the opening, in the slideshow, we had a big push over the last year or so with some important developments. One of which was Jaden's addition of the Brainflow backend, and that allowed us to move from being principally, exclusively a Muse device tool to being to having a much kind of broader vision, basically. And this is all hats off to Andre for developing Brainflow, which allows device support for a large number of mobile devices. But as a result of that, now what we have this basically expanded vision, if you like, that we're aiming for providing this service, or having this library that can be used for not every single device that exists, but we basically want to be the place to do mobile EEG experiments, whatever device you have, right? And we're moving towards that situation now we're covering some of the main bases now with BrainFlow in terms of the OpenBCI and some of the emerging devices like the Notion as well. Some stuff on the code that I won't go into, but just a quick flavor of the type of experiments. And again, a lot of these really go back to Alexandra for implementing, but they're classic EEG experiments. Is faces versus houses, rapid serial visual presentation experiment, which is a really nice task that pulls out an ERP difference, this N170 waveform that distinguishes face. It's like a face responsive brain response, face selective brain response. Comes out pretty reliably from a Muse and from an OpenBCI with roughly 10 minutes of data, which is cool. We have P300s. We have steady state visual evoked potential. We have steady state auditory evoked potential. We have I had the experiments list back there, but we have auditory oddball. We have this visual cueing task that Kyle Mathewson put in, which is actually really cool, kind of spatial visual attention. The library's growing, so we're trying to pull in and implement kind of a wide set of cognitive neuroscience experiments that I with the criterion that they need to give us some kind of signal, some kind of distinctive response, ideally with without too many trials. But we're building out the library, starting with the kind of classic experiments and then broadening out. And yeah, like again, without going into too much of the details, because this is just a quick version of the talk. Like one of the things, just to wrap up then, as I was saying, we're expanding in terms of number of experiments. So I've said a little bit about devices, we're expanding there. Maybe a quick comment then about the horizons for this. So I see a role for this type of technology in a clinical innovation space as well as an education space. So this is where I'm coming from in terms of my particular applications. There are other applications that we're also working with people on that are more in, let's say, a kind of consumer neuroeconomics, consumer kind of electronic space. So that would be another area where you could see a lot of action going on there. But particularly in the education and in the clinical domain, where there are, in the case of context of education, like you want to be able to teach kids how to do brain research, or I want to be able to teach kids how to do brain research, and you want to be able to give them, hands-on experience trying out some things that are the type of things that we study as neuroscientists. So this is something that is really kind of opening up the space for having more of that in a curriculum that we really appreciate. And at the clinical level as well, there's some realization that there are things we can do with mobile EEG that could be useful in diagnostic and prognostic scenarios, in areas like neurodegenerative disease and in psychiatric conditions that I study as well. So we're exploring the options in terms of how we can deploy the paradigms that we have here in those contexts as well. And I'm happy to talk more about the details of those as well. Okay, I'll call it a day there. There is the URL, so please go and check out the repo. Apologies for my brain fart a little bit earlier on. It is nearly midnight here in Toronto, so I'll excuse myself a little bit on that. And I'll close my screen share and happy to address any questions that people have.
For those who want to learn
Yep.
more,
Hey.
about EEG notebooks, come join us on the Hacknight, Tuesday Hacknights.
Yeah, yeah. I touched. Yeah, this is something that we can say a bit more about. So, we, as in the EEG notebooks developer team, Morgan, Jaden, myself, a few other people, and we've been working with some folks from OpenBCI, who I think, yeah, Richard is here. So Richard and Joe from OpenBCI, on a new series of events that. Hi, Richard. Yeah, cool. Which we're calling the NeuroTech Challenge series, and what it's going to be is a set of projects that are going to be based around mobile neurotech that we're looking to kind of provide the opportunity to participate in some scientific research for people who have access to and some interest in doing some brain recordings on themselves. So what we have coming up is a study that's going to run this year, and it should, fingers crossed. There are a few things that still need to be ironed out, but we're hoping to start in February. The idea is going to be we're working on streamlining it, but it's essentially going to be, we're going to be offering you the opportunity / asking you to participate in our study, where you download the EEG Notebooks tool, you turn on your EEG device. It could be a Muse, could be an OpenBCI, could be a Neurosity, but we have a bit of a focus towards OpenBCI, but whatever device you have, and record some ERPs from one of the experiments I was talking about, and then we're basically generating a database. So you're contributing to science. We have some prizes as part of this, so it'll be an opportunity for you to win some gear. But the thing that you'll also be doing is contributing to science. And as I said, what we're aiming to do is develop a large scale database of. So we have an idea of like how these devices and how these paradigms work in the wild. Let's say the wild, like outside the lab. We can do a certain amount of data collection as developers and scientists in the group that we have. 5, 10, 20 people with a certain amount of hours, but we really need to scale it up. So, and we have access to this international community of people who are interested in exploring the brain and exploring their own brains. So we're looking to leverage that and really build up, ideally, a database that hits the thousands mark. If we can get that many people contributing and interested in sitting down in front of their computer for roughly an hour, like recording some ERPs, and then basically we're going to bring in the data, do a bit of processing on it, and then make it available to the world as an open access database. So that's going to be phase 1 of the NeuroTech Challenge series. Other things that we have on the roadmap for that are going to be something like a Kaggle type competition that's going to be an analysis on the data that we collect in this first phase, and that'll be an opportunity for people to really flex their ML muscles and try and get good classification performance on these data sets that we release. More details on that coming through, when we've got through phase 1. But keep an eye out for this thing. It's called the NeuroTech Challenge series. We're really excited about it. We've been putting a fair bit of work into getting it ready, and it's going to be a fun thing for all of you to do in 2021.
For the YouTube people and Twitch
Okay, I'll step off the podium and people can message me. Happy to chat about any of the things we talked about when people wanna ping me. Thanks a lot.
For the YouTube and Twitch people, he was responding to someone else's question, not what I was
So
commenting.
hello, everybody. I just want to take the chance to reintroduce Balder from Plato Science. As I mentioned earlier, Balder's a friend of mine, an awesome guy. I'll let him do a little more introduction of himself and Plato, but looking forward to his talk.
Second, and I'll get my presentation up. So I hope you all can see this. My name is Balder. I'm the CEO at a company called Plato Science. We mainly work with 3 different things at Plato Science. We do some different types of brain studies, neuro studies, everything from fMRI through FNIRS and EEG. Then we do studies on how cognitive training is changing the brain over time. So me and my co-founder Morten, who's a neurobiologist. That's awesome. As if. What about now? Okay, perfect. So the 3 things we do at Plato Science. So in the middle, the more cognitive change bit of our work. So Morten and I do cognitive training studies. We look at how different type of interventions are changing the brain over time. And then we also work with BCIs, most importantly through TDCS. So main technologies that we work with, we use fMRI for lab studies, EEG for in-context studies. We use HRV as a easy in-context mapping of the biological response to the physical effects. And finally, TDCS, which is what I'm going to focus mainly on in my talk today. I'm certain that all of you have heard about TDCS before, so I won't talk too much about that. TDCS, direct current, TACS, and other technology that we also do work with, have been used for a number of different contexts. Of course, as a lot of these technologies come from the army usage, but also in mental health and in cognitive rehabilitation. We started working with TDCS about 7, soon 8 years ago, and normal TDCS setups look something like this. So for those of you who've been participating in studies, you've probably have had big wet electrodes strapped to your head. And what these electrodes do is, of course, to induce a low direct electrical current. And the very simple understanding of TDCS, it's very far from being this simple, is that there is an increased effect, or it's easier for the neurons to activate in the area of the brain where the currents enter, and it's harder for them to activate where the current go back out. What, of course, research over the last couple of years have shown is that the effects in the brain are actually very dependent on other factors, such as how the current runs over the geometry of the brain. But this is sort of the classical explanation of TDCS. So what Morten and I started about 5 years ago was a company called Plato Science, where we wanted to make TDCS very easy accessible, both for researchers and for people at home who wanted to explore this technology for different reasons, different purposes. The first product we made is called Plato Work. It's a 3-electrode TDCS neurostimulator. It has a Bluetooth connection and a rechargeable battery. So it is controlled using a smartphone app, and I'll get back to why I think that is a very important feature about the product. But in short, what we did with Plato Work was we took a number of different type of studies from different domains, fMRI, FNIRS, EEG, TDCS, TACS, also some from TMS, and we created a number of hypotheses for how could we make a product that was targeting certain regions that are involved in what seems to be different important networks that we think that people would like to have access to modulating. And in our effort to make this consumer friendly, which I think is one of the more important things for us, is the technology in itself is so amazing. The question is more how to wrap it up in a format so people have easy access to it. And with the current version of Plato Work, we have sort of summarized different type of electroactivations and the different studies into 4 different modes. So the idea with the product is to give users access to these 4 different modes. So concentration, create, learn, and rethink. And the idea, I know, again, you guys know the complexity of this, but the idea is if you find yourself in a situation where your brain is not doing what you would like it to do, or not doing what you know it's capable of doing, you put the headset on, you select the type of activation that you're interested in, and then during stimulation and for a certain time after stimulation, you have an increased likelihood of having that type of neural activation. And one of the things that we're working on now, so we have the products in the market. We have about 100 sessions per day all over the world. We're up to, I think, more than 5,000 hours of brain stimulation logged. And going forward, one of the things we're doing is mapping TDCS, our device. In the picture, you can see a rebuilt prototype with consumer grade EEG, with HRV, and with FNIRS as different ways of investigating what can we do to increase the precision of the effects we get from the neurostimulation. One of the other things we're doing these days is we are about to launch a new product called Plato Game, which is a simpler mechanical version and a bit, I would say, more user-friendly version of the current Plato Work one. So this headset is offering the same type of TDCS, but it's designed in a way to fit with headsets like the ones I'm wearing right now. So that's a new project. If you're interested, you can sign up at our website /Plato Game. And with Plato Game, it has also opened up for doing neurostimulation with VR. This is from a Copenhagen-based VR company called Cora that do a lot of custom VR training, cognitive training. So what we're doing here is mapping the effects of their training with and without TDCS stimulation. Of other studies we currently have going, we're doing quite a big CSGO study where we've built a training court or a training track in CSGO where we have people with headsets who are going through the training, the CSGO training. And what we look at is to what extent the participants who are having TDCS versus those having sham, so feels like TDCS, but it's not having any effect, and looking at how much we can boost the increase that the players have. Then we do 2 other type of studies with a online data collection system from Cambridge Brain Sciences, just exemplified here, where we do a completely classical, rigorous 2 times 2 weeks counterbalance double-blind study with participants. So people who have our headset are going through a home-based brain training that we are then mapping with Cambridge Brain Sciences over time. So there is an external third-party assessment. And then we look at the differences between with normal simulation compared to sham over time. Then I also wanted to briefly touch on a couple of other things that are happening right now. So you all heard about Neurallink, obviously, and already presented earlier today. But for those who are interested in other implantable projects, this is an actual product from a quite big Danish company, but it seems that they haven't been very successful in getting a good outreach. So this is an implantable EEG system, which goes under the skin, but on top of the scalp, which reduces a lot of the noise that you would normally see. But on a approval side, it's way easier, of course, to work with. Then another thing that I also want to say a couple of words about is what I see as the current movement in the space of brain stimulation and in general just any type of brain reading, brain stimulation. And that's the current hype about it. So this is an opinion from the New York Times. For those who haven't seen it, I warmly recommend it, not because it's informative, but because it might give a good picture of how the outer world, the people who are not involved in these technologies, see it. Brains are talking to computers, and computers to brains. Are our daydreams safe? And I find it interesting with the hype that BCIs and product like ours are currently getting, especially because it seems to be, very often overemphasize what they could potentially do compared to what we're actually doing. Another thing that is happening is there are a lot of companies pushing brain stimulation devices in the public space. So this is, for those who haven't seen it, it's a brain stimulator, TDCS brain stimulator that was featured on Shark Tank, did not get funding. And I'm very curious to see how these different type of very sort of consumer-centric and low-cost devices will be perceived by the outer world. In the very first presentation today, sorry, I can't remember the name of the presenter, 3 different type of neurostimulation devices were presented. And I think it's very important to remember that I think we as a whole field might actually be doing ourselves disservice by overselling what these technologies can do, because there is no quick fix, there is no magic pill. So if you start selling products that can do everything and that will just fix your brain or fix you up, most of the time that's just not accurate. And for those who have not read it, I would definitely recommend this article about. So one of the products here are discussed in this article without names. And I think it's a very good example of how there are definitely companies in the space that are overselling the technology. And then articles like this has been very visible on Reddit, that to me might actually do long-term damage to the whole future field of neurostimulation if there are too much noise, negative noise about it at this point. So to close off my very quick speed talk here, I want to say a couple of things about other activities. So first of all, the importance of our app. I think the fact that we have live monitoring of our brain stimulation through an external device. So if there would be any malfunctioning in the headset itself, we can actually detect it. We can see that the stimulation is delivered as it should, and we can inform the user in the case that there would be anything not doing as it should, where a lot of the other products in the market are a bit more push a button and cross your fingers type. Another thing that we're starting hopefully next week or the week thereafter is something we call Program X and Y. And that's sort of building a bit of a bottom-up approach to neurostimulation. So we've launched 2 opposite types of neurostimulation in our app, or that's what we're doing, to our users. And then we tell them which electrodes are active, but we do not tell them what they should expect. And then we ask them to give feedback on which type of cognitive effects, what they use it for, and to what extent they see any effects. Because both these programs are understudied, I would say. So it's an interesting way of building hypotheses for future studies. Then we have reached a data set size where we can start doing a lot of interesting analyses. So right now we are doing mass analysis on some of the classical basic assumptions about TDCS. One very simple example is the idea that there will always be a decrease in resistance between the electrodes over time, which definitely doesn't seem to be the case. Another thing that we're using this data set to, and which is also sort of a gradual process, is to improve the logic which is in the calibration. So for those of you who have done brain stimulation before, as electrical brain stimulation, you know of the process it is to actually get a sufficient contact between the electrodes. And for any consumer product used remotely, it's very important for us to make sure that that process is quick and easy for the users. And the more data we have, the easier it is for us to make sure that the calibration process is good and quick. We are also building in a sham function in our app, and we'll challenge our users to open up for using sham, so we can also get sort of a placebo control of all the effects that we are recording. Then we have a science app which we're using internally that we're hoping to publish and make available for all our users and also for researchers. We call it Freestyle, where you can program exactly how you want the headset to be activated. Then Nick said a couple of things about the new movements in the regulatory field in the US. Currently, TDCS is not regulated as a technology, and that has been the case in the EU. But right now, from the 26th of May 2021, any TDCS, TACS product sold in the EU will have to have at least a Class 1 medical approval. We're luckily on track to have that in place by then, but I think it's an important and interesting move, and I hope we see something similar in the US very soon. And finally, if any of you have students or are studying yourself and would like to do a project with TDCS in context, we love working with student projects, so feel free to reach out. I've also spoke to Nick about finding a way to set up a sponsorship program so we can provide headsets through NeuroTechX. So that's my key points for today. If you have any questions, do it after this talk, or of course send me them by email. You can find us on @PlatoScience. For anyone who would consider to buy a PlatoWork headset, I've created a discount code with the name NeuroTechX15, which gives 15% off our headsets. In our web shop, I think it's only 15 of the codes, but it doesn't seem over enough people for that to be a problem. But thank you so much for listening. And for more of our research, you can look up me or my co-founder, Morten Friis Olivarius, on the webpage. And thank you so much for listening, and thanks for the invitation, Nick. Oh yeah, yes, perfect. So very good question, John. So since our device is a one circuit, you can only activate 2 electrodes at a time. You can activate more than 2, but you cannot control the cathode. So sending the current in multiple electrodes or picking it up from different electrodes, the current will go to the electrode which is the one with least resistance, obviously. And in terms of the programmability for the current device, it's very limited publicly, and that's simply because the app we have right now is designed to be sort of for people without knowledge about TDCS, but the freestyle app we have allows for full up to 4 milliampere as long short sequence you like, any combination of electrodes, sham, so forth. So do you have technical spec compared to Sothrigs? Yes and no. So the devices per se are doing the exact same thing. The place where Sothrigs is better and therefore also more expensive is the components that are measuring the currents are more precise. So I think they say they have a 0.05 or 0.72% accuracy, and ours is about 0.1, but that's in measuring. And there's sort of I'll try not to get too technical here, but there's sort of 2 aspects to the precision of TDCS. So one is the power generator. So how precise, if I ask for 0.01 milliampere, how exact will that value come, and how exact will it stay, and how quickly will it change? And depending on how you design your circuits, you can make that so it's as close as it gets to being instant. So Sothrigs and us are both using the same sort of logic. So it's the electrical generator which is driving the current. So if you change the resistance, the generator will change the current immediately. So you can sort of you could discuss how quickly is immediately, but that to me is not an important factor in TDCS. The important thing is your circuit for measuring the precision during each and every stimulation. And there Sothrigs definitely has a higher precision than we do. Our devices, if they do TACS, they don't. There's no reason they couldn't based on the circuit. It's actually a matter of the firmware. So, and we can do over-the-air firmware updates. So I'm not going to promise anything about when we will have TACS available, but it's technically possible. It's more a priority firmware issue. Thank you all for listening. And again, if you have any questions, or want to sign up for news about Play-Doh Game when that is available, then go to our website. Thank you so much for your time.
If I could introduce our next speaker, Alex Milinkovic, who is coming from Curia. Alex is a InfoSec, coming from InfoSec, and I'm not going to, he can tell you more about his transition into neurotech, but I want to just say that Alex is someone that I met in the Castro garage that Neurotech San Francisco started in. And he and I bonded over the fact that we were the two old men in the room that knew what iOmega drives were. And, it wasn't some sort of science fiction, but an old hardware company. And so if Alex has his slides ready, if he moves over to the podium. And so Alex is also a vital part of the Neurotech San Francisco team, is a videographer and Hacknights, and when we had in-person meetings was also there, providing devices. I've got some of Alex's loans here on my desk, and has kindly been a sponsor of this event for Neurotech San Francisco and NeuroTechX. So let me turn it over to Alex.
Morgan. Yeah, it's wonderful to be here. Really excited to talk about what we're working on. And it's been really, really awesome participating in the Neurotech San Francisco community. From the people that I've met to the expertise that I was able to get from just general questions. Alexander Barashant's Muse LSL library was just so useful getting started on collecting data in the Muse and also understanding those things. So yeah, it would have been an incredibly difficult journey without Neurotech. And I have to say it was an amazing resource, and I hope that it can continue to help other people speed up their knowledge of the neurotech field the same way that it did for me. So it's been incredible, and really, really happy that I was able to participate in the Neurotech San Francisco, and happy to keep doing so for sure. Okay, so let's see if you can see my screen. All right, so this is just a brief introduction of what we're doing, because really excited to talk about it. So at the start point, I'll tell you something you already know, which is that user research, kind of difficult, kind of time consuming. But I'm not really trying to state the obvious. It's just that this stuff really, really is a challenge to do any kind of collection at scale, or to actually try to bring together multiple devices or to understand them. So if you look at, the amount of time that gets spent preparing the subjects to do these collections, they have to come in on a lab. They have to go through this really uncomfortable process. It's probably not very fun at that point, because they're kind of being examined and all this other stuff. So there's a lot of challenges with doing this user research. And even further, the challenges of doing performance evaluations of any sort has this interesting stigma to it, which is that it is sort of people make some wild claims, and in general, the goal is to try to find some way to show a performance improvement, some method that'll kind of do it. And as a result, I think it kind of gets a little bit of a bad rap. So what we're trying to do is take a very data-driven, very scientific, very telemetry-oriented approach to understanding people's performance. And the way that we would like to do that is implementing these things, which is reducing that collection time as much as possible. We recently did a study with Ole Miss University. They were able to collect 3 hours, 15 minutes per subject in a 4-hour window. So that's a very lengthy session for sure. But it's a pretty good return on time in terms of, in the span of just a few weeks, they were able to collect 60 hours of data. So that was really, really cool to see that, when everything is working and automated, and, it's very nice to see those ratios for collection times. And then on top of that, the automation, the labeling, the recording of what was happening, we really felt that those things would be important. So all of those things we implemented and tried to make it as data-driven and easy to access the data as possible. So just to kind of give you an overview of the components before I get to some examples, we got the server itself. That is a fully passive system. We can spec it as a separate system for a lot of reasons. That ends up being easier for most things, but we can also have one system do the stimulus and the analysis. So we can support both, but a lot of reasons that it's easier to go with a system. Then we have this plotter software, which basically will put whatever telemetry you want on the screen at 60 frames per second. And that really kind of helps when trying to observe and watch these stimuli. Then we have these automated reports that you can start running right away as soon as the collection is done. So you can get some initial impressions of what was unique with the data, but also it's not captive to like a piece of software, proprietary or whatever. You can send these reports to people, you can print them for them right there. So it's pretty handy to be able to do that analysis right away on the static data. And then there are much more elaborate reports where you can do subject comparison of different conditions or different subjects doing the same task or whatever. And we actually support doing whole studies with examples and kind of some iterations that we've done in our data collection, to give you an example. And then finally, once the data is collected, hey, why not put it in a neural network? Why not use it for machine learning analysis? We basically got running examples that you can use to see how we transform the data to put them into the most common convolutional networks, Keras pipelines. And so it's very easy to leverage that to begin your own analysis. So looking at data-driven performance, here's an example of something I think people have seen, which is a flight data recorder. And this is how an airplane's performance is measured in terms of, okay, is it performing as expected? Is something unusual? But also the way that these metrics come together allows a person to see in context, whereas if these metrics were individualized, it wouldn't be as meaningful if one was picking one metric. But all together, and one gets a rich understanding of what's happening with the airplane. Well, okay, that's how aircraft manufacturers keep track of performance in like the most critical settings, which is a flight that didn't go well. What about like Formula One teams? Well, it turns out they use telemetry as well. I mean, these are teams that have budgets of hundreds of millions of dollars, and they want to know how their car is performing at every turn, every portion of the track. They want to know which trade-offs to go with. And so these are the tools that people use to examine performance when they're looking for a quantifiable, objective metrics-driven approach. So that's what we've tried to implement. And the first part of that is this plotter. And basically this runs right along with the collector that's pulling in all the data. It's recording the data for static offline analysis afterwards. But while the subject is performing the task, we can synchronize the display that the experimenter is looking at, and they will receive this telemetry in real time. Interestingly enough, it can also be streamed. So if a streamer wanted to actually have one of these platforms and devices and real time send it to Twitch, they actually could. No, we haven't had anyone do that, but we do support it, and I think it would be kind of fun. Another thing that we can do is we can use computer vision to process these videos and insert labels, because we have this rich information. We can tell you things like, this person's health dropped at this moment, and insert a label for it, because we're looking at their health frame by frame, and we see if it drops from its current value. That's probably going to be associated with some responses. We can look to see, did their eyes gaze into that area? Did they notice that their health dropped? So there's some really granular analysis that we can do. And one of the really cool things is that we spent a lot of time on synchronization, latency, correcting for different device drifts. And so we actually not only have a good understanding of the latencies and the synchronization overall, we actually do a machine learning based synchronization pass on each recording. So that is optional. It does take some time afterwards. And so, I mean, there might be scenarios where you might not want to do that, but for the most part, it'll make your recordings as accurate as we can make them. And it's just an automated step that happens after collection. So here's an example. We worked with Ole Miss University. They have a esports department, and they were kind enough to administer some studies, and we sent them the equipment, to do the collection. So here's the lab. It was a lot of fun working with them, and they've done 2 really cool studies. They did check out the effects of caffeine on people, and that was a lot of fun. We didn't see some super strong effects, but we did see a lot of biometric changes. So in terms of performance, we couldn't really relate it, but in terms of seeing physical changes, absolutely. And that was where we noticed this really interesting pupillary asymmetry with the caffeine that absolutely made us much more aware of pupil asymmetry in general. The other study we did with them was also a 10 subject study. So this is now 20 people total that have had the fun. And this was evaluating the effects of fatigue over 3 hours. And then on another day, they did the 3 hours again, wearing a set of gaming glasses. So we wanted to see some changes. And that was a really interesting study as well. So what was really cool to see was how many people started showing changes around the same time, which was somewhere in the 2 hours, 15, 2.5 hour mark. So we were able to see some of these coarse changes in metrics that we were hoping to see. And it was a very effective study. I think we'll be presenting the results on that to the NeuroTech San Francisco Hacknight in probably a few weeks. So an example of the reports that we can generate right after a session, and this is basically as soon as the person is done recording, this is the pupillometry section of it. So we're plotting the pupils over time. We're giving you the rate of change with a linear fit, so you can see kind of the overall trend, histograms, and then the violin plots make a very easy visual comparison. So yes, this data tells that the person's eyes were a different size and that their right pupil is larger by about 0.5 millimeter. But these visualizations really make it much easier to understand. So it's been pretty cool to be able to kind of give people these reports pretty much right away as soon as they're done doing something. And so for the most part, we've tried to come up with a way where anybody that wants to do performance research, such as, esports teams or researchers or people that have high performers, we were looking at like underwater ROV operators would be an interesting thing or whatever. This platform is meant to be fully passive and a really easy way to collect data on people doing a performance as they do it naturally. So not too much difficulty. The eye tracker and the EEGs are basically selected to just make it as plug and play as possible so that we can focus as much as possible on the analysis, because we think that's the interesting part. All right, and let me stop sharing. Okay, and I think Morgan has wandered off. So if anyone has any questions, please. All right. You're referring to the report? Yeah, absolutely. Yes. And depending on if you look at the video here, I have no idea if this is going to be watchable or not. I guess I can check, but this is what this actually looks like in action. And what's interesting is that you can really start to relate some of these pupillary shifts to what's going on. So like right here, you know, where the person's landing, it's pretty straightforward. But as they get into this room and they start navigating, you've got this gaze circle that shows you what's going on. But you can see that these structures are really kind of driven by what they're looking at and the amount of time that they're going to spend. Also, there's a close relationship between the eyes, but it's not always identical. Like sometimes, you know, here this eye showed a spike, whereas this one didn't. And these kinds of changes are interesting to us. But yeah, there is a pattern. There is an oscillation in a lot of these emissions. And we actually find that the pattern is largely subject specific. So, you know, if you look at one person doing the same task, you'll see a very similar oscillation pattern. But if you look at a different person doing that same task, you'll see a potentially different oscillation pattern. So that was kind of cool that it wasn't so global, but that it was very much person specific. And then we actually tried to train a neural network to identify the subject from their pupillary shifts. And we used 10 subjects and we got a really, really high accuracy. I think it was around 90% for something that we were training with only about an hour of data. So yeah, these pupillary emissions are very subject specific and have a very like distinctive pattern. And that really jumped out at us. It's interesting that you noticed that right away, John. And yeah, Balder, it would be interesting to hear about your CSGO study because yeah, that looked super interesting. You know, how you obtained those measurements. It would be wonderful to talk sometime later and kind of get a sense. We support the Tobii eye tracker because it's screen based, but there's no limitation on the hardware. Yes, Richard, we do use LSL as our core transport layer for all of these devices. So every one of these things generates a stream, and we subscribe to those streams in batch. We have detailed timestamping and offsets, and then we sort of reorient everything to the video afterwards so that we have a common time reference and resynchronize in that pass as well. Pupil Labs is really interesting to us as well. We have one of those eye trackers. NeuroTech SF is currently using it because we don't have the ability to run studies at the moment with COVID. But yeah, that's wonderful data. I would be super interested to see like the structure of the data format that Pupil uses, because we've used their LSL connector and we've done the 3D testing where it kind of creates a 360 sphere and it will give you the pupillary measurement and sort of angles from baseline. And from what I understand, the Pupil Labs eye trackers support several different modes of calibration. So there's like a 2D and then a 3D. There's like binocular and so on. So I'm not sure what configurations the data is in, like what coordinates or spatial dimensionality. But if it's two-dimensional, that's something that we can probably help. Like I can show you, some of the, oh, okay. So you have the 2D and the 3D. Awesome. Yeah, that's great. So in our case, we could certainly consume pupil data with what we're doing and it would make no difference. We have some ability to relate screen location to certain things. Like if you want to know how often they checked something on the screen or whatever, we can define that pixel region and tell you. With a real world based eye tracker, we're not going to have pixel coordinates on a screen, but we can definitely tell you like if you're thinking about pupil size or pupil shift, for sure, the Pupil Labs eye tracker would give a lot of pupillometry data that would be perfectly valid. And yes, Ryan, VR. Tobii has finally started making their way into several VR headsets. The new HP looks really, really exciting. It was just announced at CES. The new Index, I don't think does have it, but anyway. So as soon as somebody has an install base with a Tobii eye tracker, the tricky part is like they have to pay a price to get the full analytics off of it, but Tobii generally supports that. So if they're willing to do that, we would be able to collect full pupillometry data off VR, which I think would be really cool. Great. Well, thank you so much for your time, everyone. We're really excited about, just, hey, let's get some real world data. Let's get some real world stuff. Let's make it metrics based. And let's look at the performance of people sort of in the context of what they're doing, instead of, making these, a brain training app or whatever. Not that I'm disparaging that in any way, just our approach a little different. All right. So thank you so much. And it's been lovely talking.
Yeah. It was very cool seeing everyone tonight. I hope to see some of you all at some of the Neurotech SF Hacknights, and that some of the other chapters might start their own Hacknights in the near future, as it's always great to see what different groups are, what they are doing every week.
That scales with changes in audiovisual cues. Yeah.
So that's great. So you've got now. Did the pupil record the stimulus off the world cam?
Yeah. So there's a world video for sure. There's a world video, and it looks on the screen. So
Yeah. So for all the people still hanging out near the presentation area, that was the last presentation. There are a number of table areas where people can go and have smaller private conversations with other people if they want. Yeah. Thanks everyone for coming.
Looking at, and past work has found that the people who are more immersed in the game, basically zoned in, look more at the credit window, so they're more just interested in getting to know the financial information.
Right.
So now what I'm doing is seeing if that is different for
Yeah. Hey, for the people still in the main area, I don't know if you heard me earlier, but there are a number of breakout areas in the different corners that you can go to have smaller group conversations. And thank you all for coming tonight. Hmm. 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 The other people. Yeah, it doesn't look like many people stuck around for discussion and for afterwards. Hmm. I'm also not fully sure how conversation distance works here. Where are other people? Huh. Don't see where other people went. Oh, there Mohit is. Oh, there they are. Not sure if this is working. Huh. I can't hear the other people. Huh. That's weird. Can't hear them. Hmm. Is my video not working correctly? That's weird. Eh. Yeah, can't hear. Guess it's um hmm. Hmm. Yeah, I understand the private areas, but can't hear any of the other people. Still, yeah, still very good talks. Uh, hmm. Okay, I'll reload. Oh,
Hi,
hey.
I have a really weird question for you. I never
Yeah.
got your actual name. I always see you as Spikenaut everywhere, and I still till date don't know your full name. I'm
Yeah.
really sorry.
Oh, it's fine. Yeah, that's the common thing. It's Ryan. Yeah,
Got it.
Ryan Sternlicht. But most of the handles I use right now are Psychonaut. So yeah, I
What's Spikenaut like? I don't.
it's an old nickname I came up with like about 15, 16 years ago, and
Wow.
it's stuck around for a long time. It was originally for gaming, and then because I also do neurotech, it works pretty well
Yeah.
as a
Yeah,
nickname.
it's a good coincidence. So, what did you think about GatherTown today?
Oh, I liked it. I haven't been into the Neurotech Gather Town before, so I was just a bit new to it. But I really liked all the talks. And it was great to finally see the West Coast collaborate on a Buzz in review. Um, yeah. What did
Yeah.
you think?
I mean, like hack nights are regularly happening. You guys keep it consistent, so there's always momentum. But
Yeah.
I've seen like hack night has this specific 20-25 people who are interested, but we are not really reaching outside that.
Yeah, that's definitely a difficult thing sometimes. I know it's also considering we for years had been doing in-person weekly hack nights, including at the garage that Morgan mentioned, which but the virtual hack nights have definitely had a core group of people attending and kind of had a weekly focus, and I think it's kind of hard to like publicize the event like far enough outside of the main group. As some
Mhm.
nights it's easier than others if it's a really relaxed night and we don't have talk after talk after talk. Um, in which case it's kind of better to ask people to watch the stream. But that also can be hard because we aren't publicizing the stream outside of Noisebridge, NeuroTechX, and a couple meetup events currently.
Yeah, that's true. Yeah, that's true. But yeah, hopefully LA will be kind of revamped after this. Maybe LA community steps up a bit, and SLC is of course there. So hopefully we'll have more events and like new and newer people joining NeuroTechX or any other initiative. But yeah, that larger audience thing needs to happen. I sometimes feel because like that's the whole area where neurotech, like the core tech people are,
Yeah,
and we don't have enough to give them, and that kind of sucks sometimes in my opinion.
yeah.
But yeah.
Yeah. I think I might have figured out why the table in the other room wasn't working. I think only 3 of those seats were private room seats, and
Could you
other
show me?
where we in the foyer where um Alex and them are sitting. Yeah.
Pleasure inducing it is for a lot of found.
I got
Yeah.
you. I'll fix
Yeah.
that tomorrow.
Yeah, so only 3 of the 4 seats work. That's why I was so confused. I'm like, okay,
No, you take the
it's
seat, Ryan. I'm just gonna hang back. I'm gonna step away from computer. Like it's 1 o'clock. I'm
oh
in
yeah,
my-
yeah, you're
But yeah, whenever you guys drop off, it's cool. Fiza will drop me a message and I'll close the room. So
oh, cool. Perfect.
nice to catch up, and I'll see you around Hacknight later.
Yeah, see ya.
See ya.
To see on screen.
Mhm.
If there's a pattern that comes up that's a winning pattern, they'll trace the pattern with their eyes and things
Gotcha.
like that. You keep track of how much money, what credits you've lost or gained, things like that for every trial. And I think there is something called a PRP, post reinforcement pause, where after a person has gone on a previous trial, they just like take a longer pause before pressing the slot machine button again to start the next trial. So I think it's a little bit like that. It'll be great to see whether this PRP is related to lower or higher metric of people eye tracking. It could be people diameter, or even the total number of saccades as well, after, if that differs after a loss versus after a win, or after an LDW, which are basically losses but disguised as wins.
Right. And yeah, you could look at, right, there would be a couple of things like, what is the size of the pupil? How long does the gaze linger on the thing, either when they lose or when they win? Yeah. I think those are the quantifications that you're looking for.
What about compatibility? Just last question. I'm sorry, I'm taking up your time.
No. Here to talk. Thank you so much for sticking around.
Yeah. So what about compatibility with other? I know you mentioned EEG for sure, but what about other devices? Because I was thinking about, perhaps pairing up the once analyze this data set for a future experiment, pairing up the EEG with an FNR system and seeing whether what kind of changes can be seen in the brain, and pairing that up with eye movement. So is there some kind of room for that in the future? Are you thinking about expanding?
Yeah, and I think that's a really valid question. So because we use LSL as this sort of underlying backend for our transport, our collection, it has a couple of really cool features. It's very extensible. It's very easy to write a broadcaster for it. And all we need is a reason and access to a device, and we can probably find a way to get that data. So, if we're talking about can we add devices that we collect to, it usually only takes us about somewhere between 2 to 4 hours to get a new device, figure out how it's communicating with the system, and then build, an inlet broadcaster to send it to LSL. Once that happens, everything is abstracted, and we no longer, worry about whatever the data from the device is going to be coming into a common repo. In terms of file structure, we use 2 file formats that are pretty common. We use LSL native, which is called XDF. It's a binary format, and it's well supported. So you can find converters for it that will read XDF files, and you can find converters that will take XDF files and convert them to CSV, which is what we do. And so not only do we make the XDF, we make the CSV. And usually you can import CSVs into pretty much whatever. So an example of what our data looks like, let me pull up one of these reports that I just...
Did you say XEF or XDF?
XDF.
Okay.
Oh, really? The 4th chair? Oh, you're kidding me. Oh, no. All right.
Yeah.
Right.
So
Yeah.
sorry.
No, it's cool. Let me look at the Curia 1 second. Okay, reports. Here we
Yeah,
go.
I've used XDFs in a number of applications. Yeah, they're pretty well supported at this point. have you guys thought about putting a built-in converter so you can in the system export both a XDF and a CSV?
Yeah, it automatically we do a little bit of cleanup. We tell people when they're done running to execute a shortcut that will do all the housekeeping for them. But yeah, as part of that, we actually will convert all the XDFs into CSV. So to show you what that looks like right here, here we'll have an XDF. This is sort of what it comes in as. And then there's this XDF to CSV, which is really the library that we call. And if you see here, it just blows up a folder and every stream gets its own CSV. And the CSVs are just normal, so it's a sort of table. Oh, that sucks. But anyway, it shows you pupil size, it shows you gaze coordinates and validity and all that stuff. But yeah, this is just standard. You can take one of these and plot.
Yeah. Very cool.
So yeah, there's nothing proprietary. Again, this is probably my InfoSec background, but I just don't believe in proprietary metrics or proprietary methods.
Yeah, it should be open source, or at least you'd be willing to share it with other people.
How on earth can you trust a metric that you don't know how is being generated? And I don't mean to harp on that stuff, but every time I read someone saying, "Oh, this is your focus value," I'm like, come on.
I can't hear you.
Yeah, sorry, Ron. Did it mute again? No, hold on.
My mute.
Black
boxes don't ever answer questions.
I know. So yeah, this was a plague on the security industry. You would have all these vendors that would have these neat little proprietary algorithms, and it would tell you, "Oh, this is malicious," or "This is not." And you're like, how did you determine this? And it really was awful. So over the years, I came to understand, like, if you want to show people how you're calculating what you're doing, and the value comes in making it easy for them to get the answers they want, not on playing cutesy stuff on like, I know secrets that you don't. More like, I can make your life easier, so you should, if you want that, you can work with me.
Yeah.
It also comes in, and also honesty counts. If you cannot be honest with someone who you potentially wants to work with you, or just have a general honest chat, how can you do that in the future? You could basically use the program to do whatever, and if I don't know what you're doing, you could just tell me, this is what I did, and it's the right way of doing things, and there's no way I can question something that I don't understand.
Exactly. And that's the problem with all these proprietary software in any kind of study, right? You look at these open source tools and they're wonderful and they're flexible and they're rich, but they're very difficult to install and learn. And then you have to take all the stuff you have and kind of make it fit into the tools. You go over to the commercial side and everything is easy and wonderful, but you can't touch the code. You don't know what they're doing. You can't really trust it. And that's not a fun anyway. So yeah. Our approach is like, what if we say you own the data, you own the stuff? And one of the things that we're looking to do, and I guess this will really depend on if it can work out commercially, but I would love to share the source with our customers.
Yeah.
What do you mean the source? Like
straight up, here is the source code for the analysis pipelines. If you agree to not distribute it, here you go. So like full Python source, full C# plotter source. Why not? Right. There's the security industry got over the idea of shared source being super bad. I think that why not share source where possible?
Yeah, I agree.
So that's not the same as open source, where you put it on GitHub and say, everybody can have it. But like shared source is like, if you want to use our stuff, we'll give you the source as long as you agree to keep it confidential. And I think we would be very comfortable with that.
Yeah, and cite them, of course.
Right. Exactly.
Yeah. Like, I mean, there's so many different licenses now that can work so well for allowing people to still have IP, but keep it transparent enough that people can trust it. Like some of the best security doesn't need to be a black box. I mean, like, I know a lot of the security I use, I know exactly how they're encrypting everything.
Right.
That doesn't mean it's any less secure. It just means
Exactly.
I can build the same security into a new system.
Right.
And if a lot of places think that, oh, you can't make money doing that because people can copy you. But people often, depending on the amount of time